Hi, this is the CAD/CAM Lessons channel. I invite you to take part in a training course on the basics of 3D modeling in FreeCAD. We will discuss the basic 3D modeling operations in FreeCAD. We'll do it step by step in an organized way, so you don't have to go through a dozen tutorials, and instead you can find as much information as possible in one tutorial. This training was created in parts and was previously published in short segments. If you prefer that format, I'm including a link to the playlist in the video description, so you have a choice. You can use the short lessons, or you can watch everything in one video. However, this tutorial has one lesson that wasn't published before. In this part of our FreeCAD series, you'll learn how to go from a simple sketch to a real 3D solid using part design and the pad feature. We'll also cover the key idea of fully constraining sketches so your models stay stable and editable. FreeCAD is a fully free 3D modeling program that anyone can use, and FreeCAD can be used both for hobbies and commercially. FreeCAD is a program from the group of 3D CAD systems, meaning it is software intended for technical 3D part modeling. In this program, you can design parts with regular shapes, including parts for machines and devices, accessories useful at home or in the workshop, or other utility elements. In FreeCAD, you are unlikely to design freeform elements, such as decorative items or various types of figurines. For such things, Blender will be better, but if you are looking for software to model parts with regular shapes, FreeCAD can be a good choice. To start working with FreeCAD, you need to download and install FreeCAD, and you can do this by going to freecad.org. Next, we click the Download Now button. At the time of recording this tutorial, the stable version of FreeCAD is version 1.0.2. However, FreeCAD version 1.1 will be available soon. However, these versions do not differ significantly visually. So many tutorials created even a few years ago will still be current. Regarding changes in FreeCAD, they are introduced regularly, but this usually involves improving performance rather than visual changes. Most changes happen inside the software. From version to version, the software works more stably and predictably, and the interface is not changed heavily. So many tutorials, even from a few years ago, are still valid, and thanks to this, we have a really huge knowledge base when it comes to learning FreeCAD. As you can see, we can install FreeCAD on Windows, Mac, and Linux. To do this, we simply download the installation file, install it, and we can use FreeCAD right away. You don't have to register anywhere, you don't have to provide your data, you simply download, install, and can start creating your own 3D models. I will be recording this tutorial on the FreeCAD 1.1 release candidate version. This version is a polished developer version. If the official stable version of FreeCAD 1.1 is not yet available, you can download this version from the development versions. To do this, click the Weekly Builds button here. And here we look for the release candidate version. Here we download the version for our operating system. You can have both the stable version and the development version installed on your computer. However, regarding the release candidate version, this version is polished, and I think you can use such versions. Unlike development versions that are not described as release candidate versions, errors may appear in those versions, so for beginner users, I do not recommend installing them. I recommend using the release candidate version or the stable version. Okay, regarding FreeCAD installation, it proceeds as standard, and after installing the software, we launch FreeCAD. FreeCAD will start with a start page with initial settings, and here we specify the language, unit system, and navigation style. Regarding the navigation style, choose the Blender navigation style because I will be using this navigation style in this tutorial, and I will be using the dark theme here. As for the Blender navigation style, later in the tutorial, once we have a 3D model, I will discuss this navigation style, but if you hover your cursor over this spot, a tooltip window will appear with information on how navigation works using this style. Regarding FreeCAD, FreeCAD has a modular structure. We have over a dozen different modules for different applications here. However, in this tutorial, we will mainly use the part design module. In this module, work consists of creating a model based on features and parameters. We build the model based on 2D sketches. That is, first we create a 2D sketch, and later, based on the 2D sketch, we apply a solid operation to create a 3D solid. To start working in this module, we click the Parametric body button. As you can see, a body appeared here, and a body in FreeCAD defines one single solid. Recently in FreeCAD, we can use an experimental option that allows creating several single solids within one body. However, for beginners, I recommend working in such a way that we ensure one body is one single solid. If you want to create more solids in the project, simply create another body. We have the Create Body button here, and we can create another part. In this tutorial, we will focus on this, and I will stick to the rule that there is one single solid in one body, and in a moment, we will move on to creating such a solid, but I will say a bit more about the interface. Regarding the FreeCAD interface, we can customize it here in the case of these icons. We have several different groups of icons, and we can change the position of each of these groups. So your FreeCAD menu might look slightly different from mine, but we can customize everything here to suit our needs. If you don't have a certain group of icons, right-click here, and you can enable or disable the visibility of the selected icon group. I mention this at this stage so you won't be surprised if certain commands are in a different place for you. It might be so. It might happen that certain icon groups are in a different place, but that is not an error. We can simply customize the FreeCAD interface. Regarding the commands available under the icons, these commands are also available in the drop-down menu. The drop-down menu is invisible in the recording, but if you expand the part design menu, we have the commands there that are available under the icons. So you can also find these commands in the drop-down menu. And as I mentioned, the basis for creating a 3D model is a 2D sketch. To create a sketch, we select the Create Sketch command. Now we indicate the plane on which we will create such a sketch. We have the basic planes of the coordinate system here, the X, Y, X, Z, and Y, Z planes. We will create a sketch on one of these planes. Let's choose the XY plane. This is the plane as if we were looking from above. We click the left mouse button here, and now this plane is the sketch plane. What you might notice is that the module has changed here. We have been switched to the Sketcher module, and the Sketcher module and the Part Design module are closely linked. It works such that in the Sketcher module, we create 2D sketches based on which we can create a 3D solid using 3D solid operations available in the Part Design module. Regarding these icons, just like in the previous case, we can also change the position of selected icon groups. I will change this a bit so that it is arranged this way, because we will also use these commands sometimes. Since we have some space on the top bar, I will place these icons here. Here we have commands for drawing 2D geometry, and here we have constraint commands. We have dimensional constraints and geometric constraints. Creating 3D models in 3D CAD systems, we usually design parts with precisely defined dimensions. These are accurate parts. For example, when creating a plate with holes, we want the plate to have specific dimensions and the holes to be properly positioned. And that is exactly what we do in a 2D sketch. We will create a simple plate here, and we will start by drawing a rectangle. Select the rectangle drawing command. Regarding drawing a rectangle, we draw it by defining two vertices of the rectangle. We click the left button defining the position of the first vertex, and we click the left button defining the position of the second vertex. What you might have noticed is that while drawing the rectangle, we can specify its dimensions. Creating geometry in FreeCAD, we can define its dimensions during creation. This applies not only to the rectangle, but we can also do it with other geometries. As you can see, the rectangle command is still active, and I can draw more rectangles. I will draw a rectangle here with dimensions of 100 by 70 millimeters. I type 100 millimeters, press enter, and here I type 70 and press enter. To end the command, click the right mouse button. Now, what is the difference between these rectangles? Regarding the rectangle that is not dimensioned, I can change the dimensions of this rectangle, and I can change the position of this rectangle. Regarding the rectangle where there are dimensions, I can no longer change the dimensions, but I can still change the position of this rectangle. This is another important thing. When we create 2D geometry based on which we will create a 3D model, this geometry should be dimensioned and should have a defined position. We can define the geometry's position relative to other geometry or relative to the origin of the coordinate system. In this case, we have two geometries, but I don't need this rectangle, so I select this rectangle with a selection box and press delete to remove this rectangle. One rectangle remains here, and this rectangle is dimensioned, but the position of this rectangle is not defined. We have 2 degrees of freedom here, and when creating 3D models based on 2D sketches, we aim for the sketch to be fully described so that there are no degrees of freedom. We simply must aim to ensure that the position and shape of the sketch cannot be freely changed. In this case, we can do it, for example, by defining the distance of this rectangle corner from the origin of the coordinate system. To do this, select this corner of the rectangle and choose the dimensioning command. I will tell you right away that we have different dimensions. We can choose a specific dimension we want to apply, but we also have a general command that is selected by default. If we select this command, by dragging the cursor in the appropriate direction, we can define the dimension we care about. Usually, this command selects the default dimension. For example, if we want to dimension a circle diameter and choose this command, the dimension defining the circle diameter will be selected. This will be clarified in a later stage of the course. But now I had this corner selected. I selected the dimensioning command. Now I drag the arrow down and type, for example, 30 millimeters here. The dimensioning command is active. I click on this point, drag the cursor to the left, click the left mouse button to define the dimension position, and type, for example, 20 millimeters here. I click the right mouse button to cancel the dimensioning command, and we have a green sketch here. This sketch is now fully described, fully constrained, and this means we cannot freely change the shape and position of this sketch. If I want to change something, I must do it consciously by editing the dimensions. To edit a dimension, double-click the left mouse button on the dimension you want to edit. We enter a new value, for example 120, press enter, and the changes are applied. Here, grabbing any geometry, any point, I cannot change the shape and position of this sketch. This is what we try to aim for, because in the case of more complex geometries, there are many places where we are exposed to accidental damage to the sketch. At first, it might seem insignificant, but if you start creating more complicated and complex shapes, you will see that aiming for the sketch to be fully constrained is actually essential to create correct geometry. Now we will create another geometry here. We will create a circle, select the Draw Circle command, and let's draw a circle more or less in this spot. To draw a circle, we click the left mouse button, and here we can create a circle of any diameter, or while creating the circle, we can enter a specific dimension. Enter 30 millimeters here, for example, and press enter. The circle drawing command is still active. You can cancel this command, but I will create another circle for demonstration purposes. I click the first point to define the position of the circle's center point, and I click the second point anywhere to define the circle's diameter. I click the right mouse button to cancel this command. This circle does not have a defined diameter. I did not specify this diameter while drawing the circle, and the diameter of this circle is not defined. In this case, we defined the circle diameter as 30 millimeters, and here I cannot change the circle diameter. I can still change the position of the circle's center point, but I cannot change the circle diameter. In this case, I can change both the center point position and the circle diameter. Now notice what happens. I select this circle, choose the dimensioning command, and the dimension defining the circle diameter was automatically selected. I can enter the circle diameter here. I click the right button to cancel this. Now the circle diameter is defined. I select this circle and press delete. This was just for demonstration. Now let's go back to this circle. I would like this circle to lie in the center of the rectangle. At this moment, the position of this circle is not defined at all. I can place this circle anywhere, but I want this circle to lie exactly in the center of the rectangle. In this case, we can use dimensions for this. For example, we can define the distance of this point from that point. Regarding adding dimensions, we can do it by first selecting the geometries between which we want to add a dimension and selecting the dimensioning command. Here I type 60 millimeters and press enter. I click the right mouse button now to cancel the dimensioning command. Now the center of this circle is placed at a distance of 60 millimeters from this side of the rectangle. I can still change the position of this circle, but only up and down. The distance in the x-axis is fixed, and we cannot change this distance. Now I will add the distance from this point to that point in the y-axis. We can also do this by first selecting the dimensioning command and indicating the 2 points between which we want to add the distance, and clicking the left mouse button. Here we can do it by entering a mathematical operation. We can use mathematical operations here. I can simply type 70 divided by 2. I click OK, and a dimension of 35 millimeters has been applied here. I click the right mouse button to cancel this command. Now this circle lies in the center of the rectangle. Based on this sketch, we will create a 3D solid. To do this, we close the sketch. The most basic operation for creating 3D solids in 3D CAD systems is the operation that allows creating a solid by extruding a sketch to a specific height. In FreeCAD, this is the pad operation. Select this operation. Here we specify the height of the solid. We can do this by dragging this arrow, or we can enter a specific value here, for example 20 millimeters. To update the preview, click the left mouse button next to this field and click OK. Now you've created your first FreeCAD solid the correct way. A fully constrained sketch turned into a 3D part with pad. Okay, we have this simple model, and by the way, I will show you one of the huge advantages of FreeCAD and other parametric 3D CAD systems. What we do in these systems is build a model based on features and parameters, and during the creation of the 3D model, every step is saved in the operation tree. We have the operation tree here. At this moment we have one operation, but if there were more operations they would appear here. The point here is that while creating a 3D model, we have access to the operation history all the time. We can go back to previous operations and make changes there. If you now wanted to make changes to this solid, for example, you wanted to change the height of this solid, you can simply edit the pad operation. To do this, double-click the left mouse button on this operation, and here you can enter a new value, for example 30 millimeters. Click OK, and the changes have been applied to the solid. Similarly, you can also edit the sketch based on which the pad operation was created. To do this, expand the pad operation. Here we have the sketch based on which this solid was created. To edit the sketch, double-click the left mouse button, and we can change the dimensions here. For example, I will change this dimension from 120 to 150 millimeters. And notice what happened. This dimension has been changed, but at this moment, the circle no longer lies in the center of this rectangle. We will come back to this in a moment. But now we close the sketch, and as you can see, the changes have been introduced to the solid. Now let's return to editing this sketch. This circle currently no longer lies in the center of this rectangle because the position of this circle was strictly fixed, and this circle lay in the center of the rectangle only in one specific case, where the lengths of the rectangle sides are 150 and 70 millimeters. If I now change, for example, this dimension to 90, this circle no longer lies in the center in any axis of the rectangle. Now, for this circle to lie in the center of the rectangle, we need to edit the position of the circle's center, and we do this by editing the dimensions. Here we enter 75. Here we enter 45. And now this circle lies in the center of the rectangle again. But if I now change this dimension from 150 to 100 millimeters, well, we have a problem again, and this circle does not lie in the center of the rectangle. In such cases, we can become somewhat independent of dimensions by using geometric constraints. If, like in this case, for example, you want this circle to always lie in the center of the rectangle, it is better to use geometric constraints here, not dimensional constraints. Dimensional constraints define one fixed, specific position. We define a specific distance between geometries, but as you can see, cases may arise where a dimension might be changed. Then it is better to apply relations between geometries and specify that a point, for example, should lie between 2 points, and this should be done independently of the geometry dimensions. I will show you how to do this on this example. First, I will remove the dimensions defining the position of the circle center. Here, we can apply a symmetry constraint between points. I click the left mouse button outside the geometries to make sure all geometries are deselected. I select this point, and select this point, and choose the symmetry constraint. Now this circle lies in the center of this rectangle, and will always lie in the center of the rectangle, regardless of what the dimensions of the rectangle sides are. We close the sketch, and the changes have been introduced to the solid, and this circle will always lie in the center of the rectangle. I go to edit the sketch, and here we just applied a geometric constraint. We assigned a relation between geometries, and this relation specifies that the center of this circle lies between the corners of the rectangle. This is one of the basic relations. Applying such relations in some cases will allow you to become independent of the model's dimensions. If in the future you need to change some dimension of the model, you just need to change the dimension you care about. And as in this case, the position of this circle will always be in the center of the rectangle. Another basic constraint is the coincidence constraint. This constraint specifies that 2 points lie in the same place, or a point lies on a line. In this case, we place the corner of the rectangle at a specific distance from the origin of the coordinate system, but we can do it so that the corner of the rectangle lies exactly at the origin of the coordinate system. To do this, I will remove these dimensions, At this moment, the position of the rectangle is not defined, but notice that the position of the circle is already strictly linked to the rectangle. These geometries are linked to each other. Simply the position of the rectangle is not defined relative to the origin of the coordinate system. We can do this in such a way that we place this corner of the rectangle at the origin of the coordinate system. To do this, we select this corner, we select the origin of the coordinate system and choose the coincidence constraint. Now the sketch is fully constrained, we close the sketch and we have a solid created based on this sketch. In a moment we will move on to the next simple example, but on this solid I want to show you the basic issues with adding fillets and chamfers. If you want to add a chamfer or a fillet, you can do it based on an edge or based on a face. You can do it in such a way that first, with the control key, you select the edges to be chamfered or filleted. You can select one or more edges and choose the operation. In this case, I selected the fillet operation and here we specify the radius value. We click OK, and in this way, we can add fillets. By the way, I will also tell you about navigation. If you want to rotate the model, press the mouse wheel and simply move the mouse. If you want to zoom in or out of the model, we do it using the mouse wheel. We simply rotate the mouse wheel. If you want to pan the model, press the left and right mouse buttons simultaneously, and you can move the model. Okay, I will now proceed to adding chamfers. With the control key, I select two edges, choose the chamfer operation, and here I specify the chamfer dimension. I click OK. In this way, we can add chamfers and fillets. We can also do it such that we first select the operation and then indicate the edges to be chamfered or filleted. I will remove the chamfer operation. I select this operation, click the right button, and select Delete, or simply press the Delete key on the keyboard. On a Mac, we do this using backspace. And now, like this, I select the fillet operation, and here I indicate the edges I want to fillet. Now, if we select the operation first here, we have the advantage that we can indicate edges simply by clicking the left mouse button on the edges. We don't have to hold a key. Here we specify the radius dimension. Click OK. If you want to edit this operation and, for example, want to add more edges to be filleted, simply go to Edit the operation, click the Select button, and you can indicate subsequent edges to be filleted. Click Confirm Selection. OK. And another edge has been added, and if you want to remove an edge from the fillet, go to Edit this operation. Double-click the left mouse button, now select the Select button, and we can indicate the edge on the model again, and this edge will be removed and will not be filleted. We can also remove it from the edge list. Simply click on this element in the edge list, and this element will be highlighted on the model. Press Delete or Backspace, and the edge has been removed and will not be filleted. The chamfer operation works similarly. We can also select this operation first and indicate the edges to be chamfered. Only here in this case, I think we first need to select the Select button, and now we can indicate edges to be chamfered. I don't know why the Select button had to be pressed first. In the case of filleting, we could indicate edges automatically, and these edges were added to the fillet. In the case of chamfering, we first click the Select button and indicate the edges we want to chamfer. Regarding the chamfering and filleting operations, this operation also works based on a face. We can fillet or chamfer all edges of a selected face. We indicate the face, select the operation, specify the chamfer or radius dimension, click OK, and all edges of the selected face are chamfered or filleted. Regarding saving files, we do this as standard from the File menu. We select Save As and specify the file name and location. Similarly, if we want to open a previously saved model, from the File menu we select Open and indicate the location and name of the file we want to open. This works as standard, just like in other programs. I will now move on to creating another project. I close this project without saving changes and create a new parametric part. Here, just like before, we will start by creating a sketch on the XY plane. Here we will practice the symmetry constraint a bit. We will start by drawing a rectangle, but this time we will choose the center rectangle command. That is, it is a command that allows drawing a rectangle such that first we define the center point of the rectangle, and then we define the position of the rectangle corner. Select this command regarding the center point of the rectangle. We will place this point at the origin of the coordinate system. If you hover the cursor over the origin of the coordinate system, this point will be highlighted and a coincidence constraint symbol will appear next to the cursor. This means that if we click the left mouse button here now, the center point of the rectangle will be automatically constrained to the origin of the coordinate system. An automatic coincidence constraint will be applied here, linking the rectangle's center point with the coordinate system's origin point. Now, while drawing the rectangle, we can specify the dimensions of this rectangle. Here type 120 millimeters in the x-axis, press enter, and in the y-axis type 100 millimeters and press enter. I click the right mouse button to cancel the rectangle drawing command. Now the rectangle is fully constrained, fully described, the dimensions of the rectangle are specified, and the position of the rectangle is also defined. Here an automatic constraint was applied. In most cases, automatic constraints work well and are very useful, but sometimes situations can arise, especially when there is a lot of geometry close to each other, where we might accidentally apply a constraint we didn't intend. This will of course become more understandable to you if you start creating more complex projects in FreeCAD, but if you would like to disable automatic constraints, you can do it here. Expand these options, and here you have the options for auto constraints and auto remove redundant constraints. Sometimes these options might not work correctly, and sometimes your sketch might turn orange. An orange sketch usually means that this sketch is over-constrained. This sometimes results from the fact that during geometry creation, automatic constraints were applied, but not all redundant constraints were removed, or if you add constraints yourself, there are too many of them, and the sketch is over-constrained. This information also appears here, and there is also information about which constraints are redundant, and then usually it is enough to remove these constraints from the constraint list. Now I will try to do something like this. You don't have to do this. I just want to show you what this is about. I select Draw Circle and will draw a circle anywhere, for example, with a diameter of 30 millimeters. I click the right mouse button and now I will turn off the removal of redundant constraints. Okay, so I select the center of the circle, select this line and choose the coincidence constraint. Now I will place this circle between these 2 points. I select 2 corners of the rectangle, select the center of the circle and choose the symmetry constraint. And here the information appeared that we have a redundant constraint, and the redundant constraint is constraint 14. In this case, the redundant constraint is the coincidence constraint I applied to place the center of the circle on this line. This constraint is redundant because by applying the symmetry constraint between the rectangle corners, we automatically place the circle center on a line lying between these corners. So this constraint in this case is a superfluous constraint. Now, if something like this appears for you, don't panic. In this case, it is enough to remove the redundant constraint. I click the right mouse button, select delete, and now the center of the circle has been automatically placed between these 2 corners of the rectangle, and the symmetry constraint also ensures that the center of the circle lies on this line. Now I will press Ctrl Z to go back to that moment. I turn on the option to remove redundant constraints and will do the same thing I did before. I add the coincidence constraint here, and now I add the symmetry constraint. In this case, FreeCAD automatically removed the redundant constraint. So when creating geometry in FreeCAD, you will very likely encounter the sketch changing color to orange, and the first reflex of many beginners is slight panic and slight consternation. But you don't need to panic. Just pay attention to what is written in this place, whether there are redundant constraints. At this moment, I will remove this circle, and now we will practice constraints a bit. I select Draw Circle, and I will draw the first circle more or less in this spot. We will make a circle with a diameter of, for example, 15 millimeters. Okay, and I will draw the second circle in such a way that the center of the circle lies on the x-axis. I hover over the x-axis. The x-axis is highlighted and a coincidence constraint symbol appears next to the cursor. As you can notice, in this case, a coincidence symbol appears that binds a point to a line. If I hover over a point, a coincidence constraint symbol appears that binds a point to a point. It is one and the same constraint, it just has different symbols. If we want to constrain a point to a point, something like an X appears, and if we want to constrain a point to a point lying on an arc appears. In this case, we happen to want to apply this constraint. We want to constrain the center of the circle to the X-axis, and I want to do it automatically. Therefore, I hover over the X-axis. When the X-axis is highlighted and this symbol appears, I click the left mouse button and draw a circle of any diameter. I click the right mouse button to cancel the circle drawing command, and I have a drawn circle whose center is constrained to the x-axis. I can change the circle diameter because I did not specify the circle diameter while drawing this circle, and I can change the position of the circle center, but I can only change the position of the circle center along the x-axis. We can also apply such a coincidence constraint manually, as you have already seen. We simply select the point, select the line, and choose the coincidence constraint, or simply press the C key on the keyboard. If you hover over the command, a tooltip window appears, and some commands have keyboard shortcuts, and in this case, the coincidence constraint is the C key. I press the C key, and the circle's center point has been constrained to the x-axis. In this case, I would like to apply a symmetry constraint between the centers of these circles so that they lie symmetrically relative to the y-axis. In this case, instead of applying a coincidence constraint, I can apply a symmetry constraint right away. I select this point, select the y-axis, and choose the symmetry constraint. The symmetry constraint is the S key. I press the S key, and here this point automatically jumped onto this line. Simply, the symmetry constraint specifies that these 2 points lie symmetrically relative to the y-axis, which also means that this point will lie on the x-axis. Now, if I change the position of one circle, the position of the other circle also changes so that symmetry relative to the axis of symmetry is maintained. In this case, the axis of symmetry is the y-axis. And another thing is I would like these circles to have the same diameter. I can, of course, select this circle, choose dimensioning. Dimensioning is the D key. I press the D key, define the dimension position, and type 15 millimeters. And now the diameters of these circles are the same, but if I now want to change the circle diameter from 15 millimeters to 20 millimeters, I have to change the diameter of 2 circles. In the case of 2 geometries, it is not difficult, it is not time-consuming. We can do it easily, but if there were more of these geometries, if, for example, we had 20 circles of the same diameter, and later it turned out that we need to change the diameter of all circles, then it is pointless to click on each circle and enter a new value. We can apply a relation here that specifies that the dimensions of the geometry are equal. I will remove the diameter dimension of this circle, and to do this, to specify that the dimensions of these circles are equal, I select these 2 circles and choose the equality constraint. The equality constraint is the E key. We can click this icon, but we can also click the E key on the keyboard. Now, the diameters of these circles are equal. If I now change the diameter of this circle, the diameter of this circle will also be changed. I will return to the value of 15 millimeters here, and the circle diameter has also been changed. Here, what you might notice is we have 1 degree of freedom. You can click on this, and the geometries where some relation, some dimension is missing will be highlighted here. Before you add a dimension or relation, I suggest clicking the left mouse button outside the geometries to deselect all geometries. Sometimes after clicking in this place to highlight degrees of freedom, not everything might be clear. That is why I often simply drag some geometry gently to see where I can move this geometry. In this case, a dimension is missing. In this case, a dimension is missing defining the position of these circle center points either relative to each other, or relative to other geometry, or relative to the origin of the coordinate system, and here we will do it such that we define the distance between the centers of these circles. I select the center points of these circles, press the D key on the keyboard, and here I enter 70 millimeters as the distance between the circle centers. And the sketch is fully constrained. The sketch is green, and now we can no longer freely change the shape and position of these geometries. I click the right mouse button to cancel dimensioning. Now we will proceed to creating more geometries. We will draw more circles. I will draw a circle more or less in this spot, and I will draw a circle more or less in this spot. I intentionally do not specify the diameter of the circles. I click the right mouse button, and now we will apply the equality constraint. I select these 3 circles and choose the equality constraint. And now these newly created circles also have a diameter of 15 millimeters. Regarding the symmetry constraint, we can also apply the symmetry constraint between a point, and so I would like to place these circles we created a moment ago symmetrically relative to the origin of the coordinate system. To do this, first we select the geometries we want to place symmetrically, and finally we select the geometry that is to be the symmetry geometry, and we select the symmetry constraint. Now it works such that these points are arranged symmetrically relative to the origin of the coordinate system. Here, of course, we can change the position of these circles quite freely, but they are arranged relative to the origin of the coordinate system all the time. And to remove the degrees of freedom, we need to define the position of one circle. In this case, we can do it by defining the distance of the circle's center point from the rectangle corner. I select these 2 points, press the D key, and here in the x-axis I enter 15 millimeters, and I will do the same in the y-axis. I also enter 15 millimeters as the distance between these points. I click the right mouse button, and even though I defined the position of only one circle thanks to the fact that we had the symmetry constraint applied, the position of the second circle was also fully defined. And, okay, not to complicate this example any further, I think this will be enough for us at this moment. We close the sketch, and based on this sketch we can create a solid of a specific height. We click OK, and we have another solid based on a sketch. Here the goal of this example was mainly to work a bit with the sketch, because the sketch is the basis for creating a 3D model, and we can create a 3D model in stages, and later in the course we will get to that. But for now, I want to focus on such basics, which in my opinion are very important. And by learning these basics, learning the basics of creating sketches, issues related to dimensioning, constraints, we are able to avoid many frustrating moments that can appear in the beginnings of learning 3D modeling. Now you know how to edit features in the tree and how to use symmetry, coincidence, and equality to keep sketches robust and predictable. Okay, we have this model, and it's a very simple model. This model was created simply by extruding a sketch to a specific height, and even if we created a more complex and complicated sketch, it will still just be a solid created by extruding a sketch to a specific height. However, FreeCAD, like other 3D CAD systems, allows building a 3D model in stages, and we can simply build the model step by step by adding subsequent segments of the model. When creating the next stage of the solid, we can use a face of the solid as a sketch plane, and we can create a sketch on such a face. To do this, select the face and choose the New Sketch command. Now this face is the sketch plane. I will draw another rectangle here. I select Draw Rectangle. I place the center of the rectangle at the origin of the coordinate system, and I would like the corner of the rectangle to be constrained to the edge of the solid. As you can see, I cannot do this right now. I can, of course, specify specific dimensions here, for example, 50 by 100 millimeters. And now, theoretically, this rectangle has the same dimensions as this solid, but as you already know, we can change individual parts of the solid. We can introduce changes. And if I enter the value 150 here now, this part of the sketch is no longer linked to the edge of the solid. I will return to the dimension of 100 millimeters here and show you what I care about. I will go to edit this sketch. This rectangle is linked to this solid only when the dimension of the solid in the y-axis is 100 millimeters. We can become independent of this. I remove this dimension, and we can apply a constraint here between the rectangle corner and the edge of this solid. However, for this, we need reference geometry, and we will create such reference geometry using the external projection command. Select this command and click on the edge of the solid. Then click the right mouse button to cancel this command, and now we can constrain this corner to this edge of the solid. I select the rectangle corner, select the reference geometry, and choose the coincidence constraint. I close the sketch, and now if I make some changes in this sketch, for example, type 150 millimeters here. Okay. This rectangle will be adapted, and the dimensions of this rectangle will also be changed. And based on this rectangle, we can create another part of the solid. I select this rectangle, choose the extrude operation, and here I will create another part of the solid, for example, to a height of 30 millimeters, and click OK. And in this way, we created another part of the solid. And now if I make changes in the first sketch, return to the value of 100 millimeters here, close the sketch, The second part of the solid has also been adapted because when creating the sketch based on which the second part of the solid was created, we applied a relation specifying that the rectangle corner is constrained to the solid's edge. In FreeCAD, we do this using the external projection operation. We simply manually indicate the edges of the solid that are to be reference geometries to which we apply relations in the next sketch. Okay, I will close this sketch and leave it as it is. And another important operation in 3D modeling in 3D CAD systems is the operation that allows removing material based on a sketch. Until now, we created a solid based on a sketch, but we also have an operation that works in the opposite way. That is, removes material from the solid based on a sketch. And this is a very important and very useful operation. We will create another sketch. This time we will create a sketch on this face. Select this face and choose the New Sketch command. And here we will create a slot. Select the slot command and draw a slot in such a way that the first point of the slot lies on the y-axis above the x-axis. Place the second point of the slot on the y-axis below the x-axis and enter 15 mm as the slot dimension. Press Enter. Click the right mouse button to cancel the slot drawing command. And here we are, still missing a dimension. First, select these 2 points and the x-axis and add a symmetry constraint here. Okay, and now select this point, press the D key, and here enter 40 mm as the dimension value. We close the sketch, and now based on this sketch, we will remove material from the solid, and the pocket operation allows this. Select this operation, and here we specify the pocket depth. Just like with the extrusion, we can do this using this arrow, or we can enter a specific pocket depth value here. Enter, for example, 15 mm and click OK. And in this way, based on the sketch, we removed material from the solid. We will use this operation again. This time, select this face as the face on which we will create the sketch, and select the external projection command, and indicate this edge and this edge. Click the right mouse button, and here we have the center points of these holes, which we will use as reference geometries where we will create circles. Select Draw Circle and hover over the center point of this circle. Click the left mouse button and draw a circle with a diameter of 20 mm. Do the same here. We also draw a circle with a diameter of 20 mm here. We close the sketch, select the pocket operation, and here we create a pocket with a depth of 5 mm, and click OK. And in this way, we can build a 3D model in stages. Regarding creating sketches on solid faces, any flat face can be a sketch plane. We will not create a sketch on a round face, but on a flat face, we can create such a sketch. For example, we will create a sketch on this face, select this face, choose the New Sketch command, and now this face is the sketch plane. And here, for example, we will draw 2 circles with a diameter of 10 mm. Okay. I did not dimension the second circle because I will apply the equality constraint here. I select these 2 circles, I press the E key, now I select the center of this circle, I select the center of this circle and select the y-axis. I press the S key, and now I select the centers of these circles again, press the D key to specify the distance between these circles. I type 70 mm here, and now I select the center of this circle. The dimensioning command is active, and we will define the distance of the circle center from the origin of the coordinate system as 30 mm. I close the sketch, and on this basis, based on this sketch, I will create holes in the solid. I select the pocket operation, and now we can do it so that I simply drag freely so that these holes go through the entire solid, but we can also use one of the operation types. We have an operation type here like through all, which creates a pocket through the entire solid. However, if there were subsequent parts of the solid here, this hole would also go through those parts of the solid. In such cases, we can use another type, for example, the up to face type, where we manually specify the face up to which the hole is to be made. I clicked on this face here, Now this face is the face limiting the hole, and the pocket will be made up to this face. I click OK, and in this way we created something like this. And as you can see, in this way we can add subsequent features, and step by step we can build increasingly complex 3D models. Now I will show you another thing that might be useful. I will add a fillet operation here. On these edges of the solid, I will create a fillet with a radius of 15 millimeters. I click OK, and now I will create a sketch on this face. And here I would like to create holes that will lie at the center point of this fillet. And for this purpose, we can also use the external projection command. We select this command, indicate the edges that are to be reference geometries. Here we have the center points of these fillets. I select Draw Circle now. I place the center of the circle at this point. I define the diameter of this circle as, for example, 10 millimeters. I do the same in this spot. Okay. I close the sketch, and based on this, I will create a hole in the solid. I select the Through All type here. I click OK, and in this way, we can also create holes in the solid. Now you can build a model feature by feature using pad and pocket, and you know how to reference edges, hole centers, and fillets with external projection. We will now move on to another simple operation that allows you to create a solid based on a 2D sketch. Let's start a new project in the Part Design module. We select the parametric body here, and we will start by creating a sketch. This time, we will create a sketch on the XZ plane. We will draw a simple shape here. Select Draw Circle. Place the center of the circle on the X-axis and draw a circle with a diameter of 30. Click the right mouse button to cancel this command. Press the D key, click on the center of the circle and define the distance of the circle's center point from the origin of the coordinate system as 50 millimeters. We close the sketch. Another simple and basic operation for creating 3D solids in 3D CAD systems is the operation that allows creating a solid by rotating a sketch around a specified axis, and this is the Revolve operation. Select this operation. Here by default, a solid was created by rotating this sketch around the vertical sketch axis. Here we specify the sketch axis, and in this case the vertical sketch axis coincides with the base Z axis. We can choose this axis. In such cases, I prefer to choose the base axes of the coordinate system, or for this operation, we can also use other geometry that will be the axis of symmetry. I will show you this in a moment. Next, we specify the angle at which we create the solid. By default, the solid is created at an angle of 360 degrees. So we have a rotation of the solid by a full 360 degrees here, but we can change this and create a fragment of such a solid. I will return to the value of 360 degrees here. I click OK, and we have such a solid. Regarding this operation, the sketch for this operation can be more complex. It can be more complicated. Here, with this simple example, I just wanted to show you the principle of how this operation works. Now, for practice, I will create another sketch. I will also create a sketch on the XZ plane and create another circle. First, I select the external projection command and indicate this edge so that I can constrain the next circle to this line. And here I will draw a circle with a diameter of, for example, 10 millimeters, and click the right mouse button. I click the Toggle Section View button to switch to the view on the sketch plane. Now I select this point. I select this point and choose the horizontal vertical constraint to place this point in one vertical line with this point. I close the sketch and select the Revolve operation. Here too, by default, a solid was created by rotating this sketch around the vertical sketch axis. We can switch this to the base Z axis, and here, for example, let's enter an angle of 60 degrees. Okay, and the solid will be created in this way. Here we can uncheck the reversed option, and then the solid will be created in this direction, or we can also check the symmetric to plane option, and then the solid will be created in two directions from the sketch plane. Click OK, and we have something like this. it is one solid. These two fragments of the solid have been joined together, but this solid is one single solid. Just like in the case of the extrude operation and in the case of the pocket operation, where the extrude operation created a solid based on a sketch, and the pocket operation removed material based on a sketch. So in this case, we have the revolve operation, which creates a solid by rotating a sketch around a specified axis. And we have the groove operation, which removes material based on a sketch by rotating the sketch around a specified axis. Now I will create another sketch. I will also create this sketch on the XZ plane. And here I switch to section view. I select the external projection command and create reference geometry to this solid. I click the right mouse button to cancel this command. And here, for example, I will create a triangle. I select draw triangle and draw a triangle more or less like this. Here I specify the dimensions of this triangle as 10 millimeters. The angle at this moment is irrelevant. I click the left mouse button to place the triangle vertex anywhere. Then I click the right button to cancel this command. And now I select this point and press the V key to place these 2 points in one vertical line. I close the sketch. And now I select the groove operation, and based on this we can remove material from the solid. Let's do it in this way for now. We remove material by rotating the sketch around the vertical sketch axis, and in this case I will also switch to the base Z axis. And here we can remove it at a full angle of 360 degrees. I click OK, and we have something like this. Now I go to edit this operation. Here we can, for example, change this angle to 60 degrees. I click OK, and that is how these operations work. These are simple operations to apply, but by combining these operations with each other, combining the extrude, revolve, pocket, and groove operations, we can create really quite complex 3D models. Now we will move on to another simple operation. We will create a new project, and I will show you an operation that in certain cases can be very useful and can shorten the time of creating a 3D model. Let's create a new sketch on the XY plane. And here I select Draw Circle, and we'll draw a circle with the center point at the origin of the coordinate system with a diameter of 100 millimeters. That is, we simply select Draw Circle, indicate the origin of the coordinate system as the place where we will place the circle center, and then specify the diameter as 100 millimeters. We close the sketch, and here we will create a solid by extruding this sketch, for example, to 15 millimeters. We enter the value 15, press enter, and now I will create another sketch on this face. I select this face. I select create sketch, and here I draw a circle and place the circle center on the y-axis. When the y-axis is highlighted, I click the left mouse button and enter 10 millimeters as the circle diameter. I click the right mouse button to cancel the circle drawing command. I press the D key to activate dimensioning. I click the left mouse button on the center of the circle, and then I define the distance of the circle center from the origin of the coordinate system. I click the left mouse button to place this dimension, and as the dimension value I enter 35 millimeters and press enter. I close the sketch, and now I select the pocket operation. And here is the pocket type. I select to first, so that the pocket is made up to the first encountered feature. In this case, the first encountered feature will be this face. Here in this case, we can also use the up to face option and indicate this face, or we can choose the to first option, and the pocket will be made up to this face. I click OK to confirm this. And now I set the isometric view. OK. And I will create another sketch on this face. I click the left mouse button on this face and select the Create Sketch command. Next, I select the External Projection command to create reference geometry to this hole. And I select Draw Circle and draw a circle whose center will lie at this point, and I draw a circle with a diameter of 15 millimeters. I close the sketch, select the pocket operation, and here I create a pocket with a depth of 5 millimeters. I click OK, and we have something like this. And now I would like to create 10 such holes in this solid, so that they are evenly distributed along a circle on this entire solid. Of course, we can sketch this. We can sketch each hole. We can apply the pocket operation. We can do it individually so that each hole is in a separate sketch. We can create 10 holes in one sketch and then perform one pocket operation. But in such cases, it misses the point. Because if these holes are to have the same diameter and are to be evenly distributed along a circle, we can use the polar pattern operation, which will make it much easier and faster. To do this, we select the operations we want to copy in a circular pattern. In this case, it will be these two operations. With the Control key in the operation tree, we select these two operations, and then we select the polar pattern command. And here, as you can see in the preview, we already have a second copy of these holes made, and here we specify the parameters of the circular pattern. We specify the axis of the circular pattern. In this case, the normal sketch axis is selected by default. In this case, this axis coincides with the base Z axis. And here, as you can see, we also have the Select Reference option, which allows you to manually indicate any geometry, but we will get to that in further examples. This option will also be useful in the case of the Revolve operation, but we will get to that. Next, we specify the angle at which we perform the pattern. By default, an angle of 360 degrees is selected, meaning this pattern will be performed on a full circle. We can change this, for example, to 180. Here nothing changed because we only have two elements, but if I add more elements, these elements will be copied only on an angle of 180 degrees. Here I will enter 90 now, and it looks like this. I return to the value of 360, and it looks like this, and here we specify the number of elements. I enter 10 here, and in this easy and quick way, we can copy features in a circular pattern. We click OK, and with literally a few clicks, we created such a solid. Of course, if there were 20, 30, or 50 of these elements, we could do it just as quickly. And using this operation has the advantage that if I now introduce changes, for example, in this sketch, and change the diameter of this hole from 10 millimeters to, for example, 5 millimeters, click OK, close the sketch. The diameters of the remaining holes have also been changed. If I now, for example, change the depth of this pocket from 5 millimeters to 1 millimeter in the remaining holes, this has also been changed. So, as you can see, in certain cases, this can have a huge advantage and can significantly speed up and facilitate the creation of 3D models. Now you know how Revolve and Groove work, and how polar pattern can duplicate features in seconds while staying fully parametric. In this part of the FreeCAD series, you'll learn how to speed up modeling using linear and rectangular patterns, plus MultiTransform for more advanced combinations. We'll also use Mirror to duplicate features cleanly so everything updates automatically when you edit the source. The rectangular pattern operation is similar in function to the polar pattern operation. This operation also allows you to significantly simplify and speed up the creation of 3D models. We will create a new project, create a sketch on the XY plane, and draw a rectangle with dimensions of 200 by 100 millimeters. Okay, we close the sketch, and here I will create a solid by extruding the sketch to 20 millimeters. Next, I will create another sketch. I select this face, choose Create Sketch, and here I will draw a circle with a diameter of 10 millimeters. I click the right mouse button to cancel the circle drawing command and press the D key to activate dimensioning. I click on the center of the circle, and we will place the center of the circle 20 millimeters from the origin of the coordinate system in the x-axis and 15 millimeters in the y-axis. We close the sketch, and based on this sketch, we will create a pocket operation. Here we select the two first types so that the pocket is made up to the bottom face of the solid, and we click OK. Now I select this face again, choose Create Sketch, select the external projection command, and indicate this edge of the hole as the edge based on which I want to create reference geometry. I select Draw Circle. I place the center of the circle at this point and enter 15 millimeters as the circle diameter. I close the sketch and select the pocket operation. And here I create a pocket with a depth of 5 millimeters. I click OK, and we have something like this. And now I would like to create more holes along this solid. Just like with the pattern, we select the operations we want to copy and select the linear pattern command. And here we specify the number of elements. Let's assume I want to create 10 elements here. As for the direction, we have the horizontal sketch axis selected here, and in this case, that matches. Here we can also select the base x-axis. Okay, and then we have the mode parameter. Here we choose either extend or spacing. If we choose spacing, we specify specific intervals between the pattern elements. If we choose extend, we specify the total length of the pattern. If you want these holes to be placed at a specific distance from each other, then of course we use the spacing option. We enter a specific value for the distance between the holes here, and these holes will be made exactly every 15 millimeters. But if you want to make a specific number of holes on the entire solid so that they are evenly distributed and the distance between these holes is not so important, then we choose the extend option. After selecting this option, we specify the total length of the pattern. So, how to determine this so that these holes are evenly distributed over the entire solid? The length of the entire solid is 200 millimeters. The first hole is offset from the edge of the solid by 20 millimeters, and I want the last hole to be offset from this edge by 20 millimeters as well. Therefore, the total length of the pattern is the length of the solid minus the offsets from the edges. So, in this case, I subtract 40 from 200 millimeters. Meaning the total length of the pattern is 160 millimeters. We click OK, and we have evenly distributed holes along this solid. Okay, we have something like this, and now a natural step when learning 3D modeling in 3D CAD systems is to try to perform such a pattern in the second direction as well, to fill this entire plate with holes. To do this in FreeCAD, we can approach it in two ways. In the new version of FreeCAD, version 1.1, this has been improved, and we can do it within a single linear pattern operation. If you now go to edit the linear pattern operation, simply double-click the left mouse button on this operation in the operation list to edit it. We have the option here to create a pattern in the second direction as well. If we check this option, we can specify the second direction of the linear pattern, and a rectangular pattern will be created. Here we select the extend option, and for the number of elements, enter 4. It looks like this, and now we need to specify the distance of the linear pattern. So, the first element is offset from this edge by 15 millimeters, and I would like the last elements of the linear pattern to be offset from this edge by 15 millimeters as well. The length of this solid is 100 millimeters, so from 100 millimeters I subtract 30 millimeters, that is 15 millimeters per side, and as the length of the pattern in the second direction, I enter 70 millimeters and click OK, and in this way we obtained a linear pattern in two directions. Just like in the case of the circular pattern, here too we have the advantage that if we introduce any changes in the source element, the changes will also be applied to the copied elements. Another approach to executing such a pattern in two directions is to perform the MultiTransform operation. Previously in FreeCAD, if you wanted to make a linear pattern in two directions, you had to use this exact operation, but this operation also has many other advantages. Therefore, it is worth getting to know this operation. This operation works by selecting the feature or features that we want to copy in a linear or rectangular pattern. In this case, I select these two operations and choose the MultiTransform operation. And here in this operation, we can combine different transformations with each other. In the next example, I will show you how we can combine a linear pattern with a circular pattern, but it works such that we click the right mouse button here and select the transformation we want to add. Add a linear pattern transformation, and just like before, we enter the linear pattern parameters here. Okay, it works like this, and now we can do it as in the previous case, where we select the second direction of the linear pattern, or simply add another transformation, another linear pattern. and specify the parameters of this linear pattern. Here we enter a pattern length of 70, number of elements 4, and change the direction to vertical sketch axis. And in this way, we also obtained what we did in the previous case. This changed in the new version of FreeCAD, and we can create a linear pattern in two directions within the linear pattern operation, but the MultiTransform operation can also be very useful in many cases, so it is worth getting acquainted with this operation, and in one of the following examples I will simply show you how you can use this operation, because within this operation we can combine all these operations with each other. So this is also an interesting operation and worth getting to know. We will now move on to another useful operation. We will create a new project, and I will show you how the mirror operation works. We discussed linear pattern and circular pattern operations, but the mirror operation can also be very useful. I will create a new sketch here on the XY plane and simply draw a rectangle here, but while drawing this rectangle we will immediately create this rectangle with rounded corners. I indicate the origin of the coordinate system as the center point of the rectangle. As dimensions for this rectangle, I enter 100 by 70 millimeters, and as the corner radius, I enter 10 millimeters. Okay, we have such a rectangle. We close the sketch, and based on this sketch, we create a solid with a height of 20 millimeters. Now I will create another sketch. I select this face, choose the Create Sketch command to create a sketch on this face, and select the Draw Slot command. I draw a slot like this. I define the first point of the slot. Then as the slot length, I enter 30 millimeters. I press enter. Regarding the position of the second point, we can do it freely. We click more or less here because in a moment we will add a symmetry constraint that will position these points for us. And as the slot width, I enter for example 7 millimeters and press enter. I click the right mouse button to cancel this command. And now I select this point, I select this point. Regarding selecting geometry in the sketcher, we simply click the left mouse button. And now I also select the x-axis and press the S key to apply the symmetry constraint here. And then I press the D key to activate the dimensioning command. Click on this point and define the distance of the slot from the origin of the coordinate system as 30 millimeters. I close the sketch, and based on this slot, I create a pocket operation. And here I select the to first option so that the pocket is made up to the bottom face. I click OK, and we have something like this. I will create another sketch on this face here. I select the Create Sketch command, and here I select the External Projection command. I indicate the slot edges as reference geometries. I select the Draw Slot command and place the first point of the slot at this point. I place the second point of the slot at this point, and as the slot width, I enter 10 millimeters and press enter. I close the sketch, and based on this sketch, I create a pocket with a depth of 5 millimeters and click OK. And now I will show you how the mirror operation works. Just like with the circular pattern and linear pattern operations, we select the features we want to mirror. Next, we select the mirror operation. Here we select the plane to use as the mirror plane. By default, the vertical sketch axis is selected, and in the preview, you can see what the model will look like. Here we can also use one of the coordinate system planes as the mirror plane. We click OK, and we have something like this. And now, just like with linear pattern and circular pattern operations, this operation has the advantage that if we introduce any changes, these changes will also be applied to the mirrored copy. So it is worth remembering this when creating 3D models, because sometimes it can really significantly facilitate and speed up the creation of a 3D model, and especially it can be very useful in cases where we make a model that has many repetitive features, and later, after making the part based on this model, it turns out that some minor dimension changes need to be made, and then instead of making changes in every feature, we simply make changes in the source feature, and the entire model will be adapted to the introduced changes. I am intentionally focusing on these operations here. And that is not all, because in another example we will use these operations again, but I want to clearly emphasize in this training that these operations really have many advantages, and in the future, before you start creating 3D models yourself, even before starting 3D modeling, you will be able to imagine the individual steps and know when to use a selected operation so that it makes the most sense and facilitates and speeds up the 3D modeling process. So I am intentionally focusing on these operations here. And in the next example, I will show you another interesting application of these operations. Now you can create full grids of holes with patterns, combine transformations with MultiTransform, and mirror pockets so design changes propagate instantly. In this part, I'll first show you a few essential tricks for selecting geometry without getting errors. Then we will push the limits of the MultiTransform tool to create nested patterns, like taking a grid of shapes and spinning it around your part in a single operation. I am recording this segment as a short supplement, and here I want to show you how you can select geometry in a sketch as well as geometry on a solid. Regarding selecting geometry in a sketch, I will create some geometry here. So, in a sketch, if you want to select one or several geometries, you simply click on the geometry with the left mouse button. And if you want to deselect some geometry, you simply click on that geometry with the left mouse button as well. We do not have to hold the Control key here. We do not have to hold the Shift key here. We simply click the left mouse button on the geometry we want to select. And if you want to deselect all geometries, click the left mouse button outside the geometries. Sometimes it is also worth deselecting all geometries preventively as a check before you choose a command, because let's assume I was selecting some geometries earlier and selected 2 points, and this might not be clearly visible. For example, let's do something like this where these points coincide with the y-axis. And now let's assume you want to apply a coincidence constraint between the center of the circle and the corner of the rectangle. And you accidentally have 2 other points selected. And initially you select the coincidence constraint command and errors appear here. Here FreeCAD tried to apply a constraint between these points, but it cannot be done this way in this case. Therefore I select this constraint in the constraint list because FreeCAD tried to add this constraint here. This constraint appeared in the constraint list, therefore first we remove this constraint. And now we preventively click the left mouse button outside the geometries, and we can apply the constraint to the selected geometries. That is why I emphasize here that sometimes, simply if we are indicating some geometries and later our concept changes, we want to do something different than we intended, it is worth preventively deselecting this geometry before choosing the next command. I think you might encounter this problem someday. And now regarding selecting geometry, we can also select geometry using a selection box. We simply press the left mouse button and drag the selection box over the geometries we want to select, and we can do this in 2 ways. The first way is dragging from left to right, and then all geometries that are entirely inside the selection box will be selected. And if we drag from right to left, geometries that are partially inside the selection box will be selected. So as you can see here, I can make such a selection box, and these 2 lines, even though they were not entirely inside the selection box, will be selected. And that was a short supplement regarding selecting geometry in a sketch. Of course, if you select geometries, you can delete them by pressing the delete key. And similarly, if we have some geometries, we can delete these geometries individually. Even if we created a rectangle here, it is actually 4 lines that we can freely delete. Okay, that was a short supplement regarding selecting geometry in a sketch and regarding selecting geometry on solids here. If you want to select several geometries, in this case, we have to do it with the Control key. And here too, we click the left mouse button on the geometries we want to select. But if there are to be several of these geometries, we do it with the Control key pressed. Sometimes situations might arise where several different geometries are close to each other. Therefore, you can switch, for example, to Edge Selection mode. And now you can select only edges. If you click on a face, nothing will be selected. This can also sometimes be useful. Sometimes it can make selection a bit easier. Here we have different modes: vertex selection mode, edge selection mode, and face selection mode, or without any mode. And then we can select all geometries. And sometimes in the case of selecting edges, the wireframe view can be useful. And in this view, we can easily select edges. This is useful, especially when we have many edges to fillet or chamfer. Then it is worth switching to the wireframe view, and we can select edges, and we can do it much faster, and it will be much easier in the wireframe view. And okay, that's it for the supplement, and we are moving on to the next part of the training. We will now move on to the next example. We create a new project in the Part Design module as a parametric part. And here I will start by creating a sketch on the XY plane and create a circle whose center will lie at the origin of the coordinate system, and it will be a circle with a diameter of 200 millimeters. I click the right mouse button to end the circle drawing command. I close the sketch and will create an extrusion of 20 millimeters. Next, I will create another sketch on this face. I select this face and choose Create Sketch, and here I will create reference geometry to this solid. I select the external projection operation, I indicate the edge of the solid and select Draw Rectangle. And I will draw a rectangle with rounded corners such that the center of the rectangle lies on the y-axis. When the y-axis is highlighted, we click the left mouse button. And as the rectangle dimensions, let's enter 10 by 10 millimeters. And enter the rounding value as 2 millimeters and press enter. I click the right mouse button to cancel the rectangle drawing command. And now I select the center of the rectangle. I select this line. I simply click the left mouse button on this point and on this line and choose the coincidence constraint. Now I close the sketch, and based on this sketch I create a pocket. And here as the pocket type I select to first. And as you can see, in this case it didn't work. And this might be because the sketch will not reach this face entirely, that here only a part of this sketch overlaps with the solid, and in such cases the to first option might not work. Therefore in this case we will use the up to face option and simply manually indicate this face. And I click OK. And now I will add fillets to the solid edges. I select the fillet command and indicate these edges. And here I will enter 2 millimeters as the radius value and click OK. And now I would like to make a circular pattern of this pocket. And I would like this circular pattern to have 5 elements that will be distributed over an angle of 45 degrees. And then I would like to duplicate these elements that will be created based on the circular pattern over the entire solid. I will show you what I mean in a moment. So first, with the Control key, we select the operations we want to duplicate in a circular pattern. It is the pocket operation and the fillet operation. And now I immediately select the MultiTransform operation. I click the right mouse button and select Add Polar Pattern. And here as the angle I enter 45 degrees. And the number of elements, 5 elements. Next, I click the right mouse button again and select Add Polar Pattern. And here I leave the angle at 360 degrees, but for example, I enter 3 elements. I click OK, and in this way, we created something like this. That is, we created a circular pattern, and then we duplicated this circular pattern in a circular pattern. And this was another example of applying the MultiTransform operation. Regarding this operation, we can combine selected operations with each other here. For example, within one MultiTransform operation, we can perform several different transformations, and I will show you this with an example. We will create another sketch here. I select this face, choose Create Sketch, and here I will draw a rectangle, also with rounded corners, such that the center of the rectangle lies on the y-axis. And let's draw a rectangle here with dimensions of 10 by 10 millimeters and with a radius of 3 millimeters. Okay, we have something like this. I click the right mouse button to cancel this command. I press the D key to activate the dimensioning command. I click on this point, and here I enter 60 millimeters as the distance of the center point of this rectangle from the origin of the coordinate system and press enter. Next, I close the sketch, and here we can create either a pocket or we can add another solid fragment. Let's just add another extrusion. I select the pad operation and create an extrusion of 5 millimeters here and click OK. And now based on this feature, we will use the MultiTransform operation, and we will do it such that we will make a linear pattern in 2 directions here, and then we will duplicate this linear pattern in a circular pattern. So it will be quite a complex operation already. We select the feature in the operation tree and select the MultiTransform command. And here initially we add a linear pattern. We select Add Linear Pattern. And here let's define the number of elements as 3 elements. And then let's change the pattern type to spacing and enter 12 millimeters as the distance between elements. And now let's add a pattern in the second direction. Here too, let's enter the number of elements as 3, and we change the axis to vertical sketch axis, reverse the direction, and here too we switch to spacing and enter 12 millimeters here. Okay, and we have something like this. We have a linear pattern in 2 directions, and now we click the right mouse button, we select Add Polar Pattern, and here, for example, we will make 3 copies of these elements. We click OK, and in this way we created something like this. And as you can see, we can combine selected transformations with each other, and in some cases this can be really very useful. Now you know the selection habits that prevent sketch mistakes, and you've seen how MultiTransform can stack patterns to build complex layouts fast. In this video, we tackle more complex sketches using the polyline and trim tools, and I'll show you how to fix those annoying redundant constraint errors. Then we'll use the MultiTransform tool to model just one corner of a part and mirror it twice to create the whole object in seconds. We will now move on to another practical example. I will start a new project as a parametric part, and here I will start by creating a sketch on the XY plane. We will create a rectangle here whose corner will lie at the origin of the coordinate system, and it will be a rectangle with dimensions of 40 by 30 millimeters. Next, we will create a slot. Select the slot command and draw a slot such that the first point of the slot is in this spot. Place the second point of the slot to the left of the y-axis. As slot dimensions, enter 30 millimeters. The position of the second point does not matter. And as the slot width, enter 5 millimeters and press Enter. Click the right mouse button to cancel this command. Now select this point, select this point, select the y-axis, and press the S key to apply a symmetry constraint here, and in a moment we will place this slot so that it lies in the center of this rectangle in the y-axis, but in this case we will delete some geometry, and probably some dimensions or some constraints will need to be added. Therefore, we will first start by removing unnecessary geometry fragments, and we will do this using the trim command. Select this command and indicate the geometry fragments to be trimmed. As you can see, when you hover over the geometry, snaps appear defining the geometry cutting boundaries. And as we hover over this line in this spot, the geometry will be trimmed from this point to this point. Okay, now I click the right mouse button to cancel this command. And here some constraints were removed and some geometries behave a bit unpredictably, so we simply apply constraints here. First, select this line and press the E key to apply an equality constraint here. Next, select this line and press the H key to apply a constraint specifying that these lines are horizontal lines. And now we just need to specify the distance of this point from that point or from the origin of the coordinate system. And we do it like this. I press the D key, click on this point, and here as the dimension I enter 15 millimeters. Okay. I click the right mouse button. We have one more degree of freedom here. Okay, a constraint was lost here, so I do it like this. I select this point, select this line, and choose the coincidence constraint. And okay, we have such a sketch. I close the sketch. And now, based on this sketch, we will create a solid by extruding the sketch to a height of 5 millimeters. We will do this using the pad operation. Select this operation, and here as the solid height, we enter 5 millimeters and click OK. And now we will create another part of the solid. Based on a sketch, and we create the sketch on this face of the solid. Select this face and choose Create Sketch. And now this face is the sketch plane. Here we will start by creating reference geometry. Select the external projection command and indicate this line as reference geometry. Click the right mouse button to cancel this command. And here we will draw a circle whose center will lie more or less in this spot. And let's make the first circle here with a diameter of 10 millimeters. And let's draw the second circle with any diameter. Let's not specify the diameter of this circle. We click the right mouse button. And I don't specify this diameter because I want this diameter to be resultant. You will see what I mean in a moment. Select the polyline drawing command. And this command is a command where we can draw several line segments using this command, because normally the line drawing command works such that we define the start point and the end point. And this line has been drawn. We can draw more lines. And if we want to draw a shape consisting of several lines using this command, we simply have to indicate the start point and end point sequentially. The polyline drawing command works such that the end of the previous segment is automatically the start of the next line segment. Okay, I click right to cancel this. I select these geometries to delete them and select the polyline drawing command, and we will do this such that I place the first point of the polyline on the y-axis anywhere. When the y-axis is highlighted, I click the left mouse button, I place the second point of the polyline at this reference geometry point. Next, I place the next point of the polyline in this spot. I click the left mouse button and draw the next segment in such a way that it is a vertical line. As the constraint symbol specifying that this line is vertical appears here next to the cursor, I click the left mouse button and click the right mouse button to finish drawing this polyline, and click the right mouse button again to cancel this command. And now I select this point, select the circle, and choose the tangency constraint. And we do the same in this spot. I select this point, select the circle, and choose the tangency constraint. Next I select this point, press the D key, and here as the value of this dimension I enter 25 millimeters and click the right mouse button to end the dimensioning command. Next I select the trim edge command and trim this fragment of the circle. I click the right mouse button, close the sketch, and based on this sketch I create another part of the solid by extruding the sketch. That is, I select the pad operation. And here the extrusion was added in this direction, and such a warning appeared. I will ignore this warning for now, but the point here is that the solid was extruded in this direction, and the next part of the solid does not touch the previous part of the solid, which was unacceptable in previous versions of FreeCAD. Now in the new version of FreeCAD, this has been improved a bit, but anyway, I don't want to perform the extrusion in this direction, I want to perform the extrusion in the other direction, and we have the reversed option here. We check this option, and now the extrusion is performed in this direction. Here we change the extrusion length to 5 millimeters, and click OK, and we have something like this. Now I will create fillets on the edges of this solid here. With the Control key I select these two edges, I select the fillet command, and here I will add a fillet with a radius of 10 millimeters. I click OK, and we have something like this. And now we'll use the mirror operation to create a mirrored copy of the entire solid. And to do this, we select the entire solid. We select the body in the feature list. We select the mirror operation. Now we just select the mirror plane. In this case, let's choose the YZ plane. We click OK, and we have something like this. Now it is one single solid, and if, for example, I introduce some changes in the sketch based on which the first part of the solid was created, for example, we change the length of this dimension to 70 millimeters, and change this dimension to 40 millimeters, close the sketch. The changes have been applied to the solid, and this was a practical example showing the advantages of the mirror operation, and we will also use this operation in the next example. And we will make the next example a bit more complex. We will create another simple but practical example now. Of course, the example itself might not be that very practical, but the method and approach to creating this model will be very practical. I start a new project as a parametric part and start by creating a sketch on the XY plane. And here we will start by creating a rectangle with dimensions of 50 by 30 millimeters. Next, select the Fill command. which allows adding a fillet in the sketch. And click on this corner of the rectangle and click the right mouse button to cancel this command. Now select this arc and press the D key. And now we can specify the radius of this fillet and enter 10 millimeters here. And next, select Draw Circle and place the center of the circle in this spot and draw a circle with a diameter of 30 millimeters. And press Enter and draw another circle whose center will lie at this point, and here draw a circle with a diameter of 5 millimeters. Next, select the Trim Edge command and trim this fragment of the circle and these fragments of the rectangle, and click the right mouse button to cancel this command. And here we have a few degrees of freedom. Okay, and let's do it one by one. I select this point, select this line, and press the C key. Next, I select this point, select this line, and press the C key. Here, the rectangle dimensions were removed. So I select this point, press the D key, and in this axis, I enter the dimension 30 millimeters. Okay. Next, I select this point, and in this axis, define the dimension as 50 millimeters. And here I click the right mouse button. We are still missing a constraint. I select this point, and press the C key, and the sketch is now fully constrained. I close the sketch, and based on this sketch, I will create a solid with a height of 5 millimeters. We do this, of course, using the pad operation. I click OK, and we have such a solid fragment. Now I will create another sketch on this face. I select this face. I select Create Sketch, and now I will start by creating external geometry to have a reference to the solid edge. We do this based on this edge. I click the right mouse button to cancel this command and select Draw Circle. And I draw the first circle whose center point will lie in this spot, and I place the second point in this spot, and here a constraint was automatically applied that linked the circle circumference to the reference geometry point. And now I draw a second circle. I place the center of the circle in this spot and draw a circle with a diameter of 15 millimeters. Now I select Draw Line and draw a line from this point to this point, and a second line from this point to this point. I click the right mouse button and select the Trim Edge command and trim the circle fragments and line fragments. I click the right mouse button. Here some constraints were lost. Okay, I'm trying to locate the places where constraints are missing. However, here, as you can see, grabbing the geometry, I cannot change the geometry position, and here it's not so much that a constraint is missing, as we have redundant constraints. Constraint number 6 is a redundant constraint, so I click on this spot. This constraint was highlighted in the list. I click the right mouse button and select Delete. Okay, constraint number 5 is also a redundant constraint, so I click the right mouse button and select Delete. And now we have 3 degrees of freedom and we can define constraints. I select this line, press the H key to specify that this line is a horizontal line. Now I select this line, press the V key to specify that this line is a vertical line, and here we are still missing a constraint. I simply grabbed this point and moved the geometry gently. And this is exactly what I recommend doing in cases where it is not entirely visible where the constraint is missing. Simply, if we grab the geometry gently, there is a small risk that we will damage this geometry, and there is a high chance that we will find the place where the constraint is missing. And now I select this point, and choose the coincidence constraint. Okay, the sketch is over constrained here, so I press Ctrl Z, and we'll do it a slightly different way. I will try to do it so that this point and this point lie in one vertical line. I don't know why the coincidence constraint didn't work here, but sometimes such situations can appear. Therefore, in many cases, it is possible to apply another constraint that will give the same effect. And actually, it's good that this came up in this example because sometimes such situations can appear, and I think you will be more aware that it is not entirely your fault, but simply you need to apply a different approach. Now I close the sketch, and based on this sketch, I create another solid fragment by extruding the sketch to 10 millimeters. I click OK, and we have something like this. And now, based on this solid, we'll create mirrored copies about the YZ plane and the XZ plane. And we will do this using the MultiTransform operation. Select the entire solid, select the MultiTransform operation, And here we click the right mouse button and select Add Mirror Transformation. And here is the mirror plane. We select the base YZ plane. Next, we click the right mouse button again. We select Add Mirror Transformation. And as the mirror plane, we select the base XZ plane. We click OK, and we have such a solid. And now, if we want to make some changes, we go to the first operation. We edit the sketch, and for example, I will change the diameter of this circle from 30 to 50 millimeters. I will change this dimension to 70 millimeters. I close the sketch, and the changes have been applied to the solid. So this is another example where I want to show you such a practical approach to 3D modeling. And sometimes such an approach can save us a lot of time, and especially it saves us a lot of time if we make a part based on a 3D model. And after making this part, it turns out that some dimension changes need to be made. And in such cases, it can save a lot of time. But also applying this approach in 3D modeling can shorten the part modeling process. You can now handle complex sketches and use double mirroring to create symmetrical parts incredibly fast. In this part of the FreeCAD series, we'll turn a simple box into a practical part using thickness to hollow it, draft text to create an engraving, and a datum plane to mirror features when standard planes don't work. You'll also learn how to move draft-based geometry into the active body so part design can use it. We will now move on to the next example. I will create a new project as a parametric part, and here I will start by creating a sketch on the XY plane. I will draw a rectangle with dimensions of 100 by 70 millimeters. And based on this rectangle, I will create a solid with a height of 50 millimeters. Okay, we have such a box. Now I select this edge and choose the chamfer operation. As the chamfer dimension, I enter 30 millimeters and click OK. And now regarding creating sketches, you already know that we can create sketches on the basic coordinate system planes, and you know that we can create sketches on solid faces. But these faces do not have to be perpendicular or parallel to the coordinate system planes. They can be slanted faces. It is important that the face is flat. We cannot create a sketch on a cylindrical face, but if the face is flat, we can create a sketch on such a face, and this face can be at any angle. And now, if we select this face and choose Create Sketch, this face is the sketch plane. Here we can use the Create External Geometry command and draw some geometry. I will create a center rectangle here and check the rounded corners option. And draw a rectangle with dimensions of 50 by 25 millimeters with a corner radius of 5 millimeters. I click the right mouse button to cancel this command. I select this point, I select this point, I select this point and choose the symmetry constraint. I close the sketch, and now based on this sketch I can create another solid fragment, for example something like this. Or I undo this operation, and based on this sketch I can create a pocket in the solid. And so step by step, combining these basic operations, we can create a 3D solid. Now, if, for example, you needed to create another sketch, you can use this face, and on this face, you can create another solid fragment. So we can start from a very simple shape, and by adding subsequent operations, we can build an increasingly complex 3D model. And okay, that was just a short piece of information, and now we will move on to the next project. Here in this case, I will use this solid we created at the beginning. I will remove these operations, and we have something like this. And another interesting operation that can be useful in some cases is the thickness operation. And this operation creates a solid with walls of a specific thickness. It works such that we indicate the face that we sort of want to remove. We select the thickness operation. And here we specify the wall thickness that is to remain. I entered 3 millimeters here. And we can create this thickness sort of inwards into the solid, or if we uncheck this, the solid will be enlarged. I will check this option, click OK. And in this way, we created such a box. I will undo this operation. Regarding the thickness operation, for this operation, we can select several faces with the Control key. In this case, I select these two faces. I select the thickness operation. I enter a wall thickness of 3 millimeters. I click OK. And now these two faces have been removed. So this is another operation that can be useful in some cases. I will undo this operation. And here, based on this solid, we will do another project. I select this edge. I select the chamfer operation. I enter 30 millimeters as the chamfer dimension. I click OK. Now with the Control key, I select these two faces. I select the thickness operation, and as the wall thickness, I enter 3 millimeters and click OK. And now I will show you how you can create a text on a solid face, and we will do this in another module. We create text in the draft module. Switch to the draft module. Here we have many other tools that can be useful, but at this moment we will focus on creating a text. And now like this, I want to create a text on this face, so I select this face and click this button to set the working plane on this face. Next, I select the Shape from Text command. This command allows us to create a text. And here we enter the text that will be created. Here we specify the height of this text, and here we indicate the font file. If you click this button, you can indicate the font file. You can use system fonts, or you can indicate some other file in TTF format. Regarding the position and height of the text, we will be able to change this later. Therefore, at this moment, these settings are not so very important. Regarding the position, we can click more or less in this spot so that it is the starting point where the text will be created, and we click OK, and now the text has been created. And regarding the height of this text, it is okay, but the position of the text does not suit me. Therefore, I select this text in the feature list. I go here to Properties, expand the Placement Arrow Position option, and here we can change the position of this text a bit to adjust it. Okay, it can be more or less something like this, and we have a text on the solid face. And now at this moment, this text is a shape string geometry. And if you would like to create a solid based on this geometry, we can approach this in two ways. We can change this text into a sketch and later simply use it as geometry for the pocket operation or for the pad operation in the part design module. And to change such a text into a sketch, we select this text here in the feature list and now select the option that allows changing draft module geometry into a sketch. It is the draft to sketch option. And this option is also in the drop-down menu. If you expand the modification drop-down menu, we have the draft to sketch option here. We select this option, and now a sketch has been created based on this. I select this geometry, press space to hide it, and here we have a sketch, and we will be able to use this sketch in the part design module. However, if we now go to the part design module, and now if based on this sketch you want to apply some solid operation, for example the pad operation, a warning will appear and there is information that we cannot use this sketch. And this is what I talked about at the beginning. We have a body element here, and the body element defines one single solid. And if we work on this element, on the body element, then all geometries we use should also be inside this body element. This sketch at this moment is outside this body, and to use this sketch to create a solid operation on this solid, we must move this sketch to the active body. To do this, we simply do it by drag and drop. We drag the sketch to the active body. Once this sketch jumped into the body, now we can use this sketch, and based on this sketch, we can create another solid fragment. Okay, and we have something like this, or I undo this operation, and based on this sketch, we can create a pocket in the solid. I click OK, and we have something like this. Now I will undo this operation. I will leave this sketch here. And here you might also notice that such a symbol appeared, and this means that the model needs to be recomputed. Sometimes this recomputation is not necessary because the model will recompute itself later in the next step, but sometimes when we do something and perform a few steps, then undo a few times, it is worth recomputing this model because it might turn out that we undid a few steps too far or a few steps too little. Therefore, if this symbol appears, simply sometimes it is worth clicking the model recomputation button. And okay, we have this sketch. I will hide this sketch. And now we have a shape string element here. And based on this element, we can also perform a solid operation in the part design module. And to do this, we also need to drag this element to the body element. And now we can use this to create another solid fragment. Here I also wanted to show you that this element created in the draft module can be changed into a regular sketch, because now if I double click on this element, I can change the position of this element here. I can introduce some changes here, but it is not a regular sketch that we create in the part design module, whereas this element, this sketch, is a regular sketch and we can edit this sketch, and sometimes this can be useful for something. Here, as you can see, this geometry is not constrained and grabbing a point can completely destroy this geometry, but we can introduce some changes and this element is simply a regular sketch that we can edit, so this can also be a big advantage in some cases. Another thing that might catch your attention at this moment is this grid that appeared here. This grid was not here before, and this grid can appear when we use the draft module, and we can also turn off this grid in the draft module. I don't know if it's possible to turn off the visibility of this grid from the part design module level. I always do it in such a way that I switch to the draft module. And here is a command that allows turning off the grid visibility, and this grid is already invisible and does not obscure the view. Okay, based on this sketch, I will create a pocket in the solid with a depth of 1 millimeter. Okay. And since we are on this example, I will create subsequent fragments of this solid here. We will simply make this into a box that we can hang, for example, on a workshop board. I will add edge fillets here. I select this edge and select this edge. And here I define the radius value, for example, 20 millimeters. Okay. And now I will create a sketch on this face. And I will do it such that I draw two circles. The first circle with a diameter of 5 millimeters, and the second circle with a diameter of 10 millimeters. Okay, I click the right mouse button to cancel this command. And now I select draw line and draw a line from this point to this circle so that this line is a vertical line. And if it won't be a vertical line, we will straighten it right away. And here I also drew a line whose start lies on this circle and end lies on this circle. I click the right mouse button to cancel this command. And I select this line and choose the horizontal vertical constraint so that this line is a vertical line. Now I select this point, and choose this constraint again to place these 2 points in one vertical line. And here, this constraint is the horizontal vertical constraint. And this constraint will be applied. That is, either the horizontal constraint or the vertical constraint will be applied, and the one that is simply closer will be applied. I will show you this with an example now. I have one line like this, and I have one line like this, and I will create one more or less like this. I click the right mouse button, and now I select this line and choose the horizontal vertical constraint, and here a constraint specifying that this line is a horizontal line was applied. Now I select this line and choose the same constraint, and here in this case FreeCAD applied a constraint specifying that this line is a vertical line. But regarding this line, here we are not entirely sure. In this case, FreeCAD happened to apply that this line is a horizontal line, but if you wanted this line to be a vertical line, you can simply use the vertical constraint here. We select this constraint, indicate the line, and now we simply manually indicated that we want this line to be a vertical line. Okay, I click the right mouse button to cancel this. I select these geometries, I press backspace or delete to remove these geometries, and here we will add more dimensions and constraints. Here we have a tangency constraint between this point and the circle. Here we don't have this constraint, so I select this line, select the circle, and choose the tangency constraint. Okay, and now like this, I select this point, I select this point, I press the D key, and here as the dimension value, I enter 10 millimeters. Okay, I don't know why the dimension lines are invisible in this view. Okay, now everything is visible. And now we will also define the distance of the center point of this hole from the edge of the solid. For this purpose, I select the external projection command. I indicate, for example, this edge. I click the right mouse button and I select this point. I select this point, I press the D key, and here as the distance I enter 15 millimeters, and I select this point. I select this point, and here in this axis, as the distance I enter 10 millimeters. I click the right mouse button to cancel the dimensioning command, and here I will also use the trim edge command and trim fragments of the circle so that it is a sketch like this. I close this sketch, and based on this sketch I will create a pocket. And here as the pocket type I select to first, and click OK, and we have something like this. Now I would like to create a mirrored copy of this hole so that it appears on the opposite side of the solid. If you try to mirror the pocket feature, you'll notice we don't have a suitable mirror plane that would place this hole on the opposite side of the solid. In this case, the mirror tool can use only the default coordinate system planes. However, this model was created with its corner located at the origin, so none of those default planes works as a symmetry plane for this hole. As a result, we can't use mirror to create the hole on the other side of the solid without defining an appropriate mirror plane first. For this purpose, we need an additional plane that will serve us as a mirror plane, and we can easily create such a plane. We can do it such that we select this face, then with the Control key, we select this face, and we will create a plane that will lie between these faces. And it is important that if you want to create such a plane that is to lie between faces, these two faces we indicate must be the same. If there were any differences between these faces, this plane would not be created correctly. And I will show you this with an example in a moment. But now like this, we select these two faces. I select the Datum plane command here. And this plane at this moment was created in this way, but we have rotation options here, and we can rotate this plane, for example, in the x-axis by 90 degrees. And now this plane lies between these faces. We click OK, and we will use this plane as the mirror plane. First, I deselect these faces by clicking in empty space. Next, I select the feature I want to mirror. I select the mirror operation. And here as the mirror plane, I select the Select Reference option and indicate this plane. And we have something like this. I click OK, and this way we've created a mirrored copy of the hole. And regarding construction planes, we can also create sketches on such planes, and this is useful in some cases. And in the further part of this training, we will use construction planes a few more times. And now I will move on to the next example and show you what I told you a moment ago. That is, if we create a construction plane that is to be between two faces, these two faces must be the same, because if they are not the same, if there is some minor difference, the plane will not be created correctly. Now you can sketch on angled faces, hollow solids with thickness, add text as real geometry, and mirror pockets using a custom datum plane. In this part of the FreeCAD series, you'll learn how datum planes work and how to use construction geometry so your sketches stay clean and predictable. We'll also solve real mirror and sketching problems when the default coordinate planes aren't enough. In this example, I showed you how to create a datum plane that lies between faces. Now I will move on to the next example and tell you a bit more about datum planes. I will create a new project as a parametric part. Generally, if you create a model and have an outline of this model, and you know that, for example, you will be creating some features through mirroring, then, if there is such a possibility, it is worth creating the model from the beginning in such a way that it is possible to use the basic planes of the coordinate system. If, as in the previous case, the starting model will be a rectangular box, you can create it so that the center of this box is at the origin of the coordinate system. Now, we will create a box with dimensions of 150 by 100 millimeters, whose center is at the origin of the coordinate system. And I will create an extrusion here, for example, to 10 millimeters. And now if I create a feature on this box, for example, I will do it in such a way that I create another rectangle here, select the external projection command, and create reference geometries based on these edges, and now I select the rectangle drawing command. I place the first corner of the rectangle at this point, and to constrain the second corner of the rectangle to this point, I define the shorter dimension of the rectangle, for example, as 40 millimeters, and I do not enter the second dimension. I simply hover the cursor over this line and click the left mouse button to constrain the rectangle corner to this edge of the solid. Now I close the sketch and create an extrusion, for example, to 20 millimeters. And we have another solid fragment, and if I want to create this solid fragment on the other side, I simply select this operation, I select the mirror operation, and here the vertical sketch axis was selected by default as the mirror plane, but in this case we can use the YZ plane. We click OK, and we have the mirror copy created. And it will be similar if, for example, we create another feature on this face, and do it, for example, in such a way that I draw a circle with a diameter of, for example, 10 millimeters here. And now we will define the position of this circle. I click the right mouse button to end the circle drawing command. I select the external projection command and create reference geometry to this edge of the solid and to this edge of the solid, and click the right mouse button. And here we can do it such that we simply define the distance of this hole from these points, but we can also create another geometry here, which will be construction geometry. And construction geometry is geometry that takes part in the sketch but does not take part in the next stage of creating the 3D model, and I will show you what I mean in a moment. I select draw line and draw a line more or less like this. Okay. I click the right mouse button, and now like this, I select this point, select this point, select this point, and choose the symmetry constraint, and now I select this point, select this point, select this point, and choose the symmetry constraint. And now this line lies in the center of the solid. And now I select this point, select the line, and choose the coincidence constraint. And now the circle lies on this line, thereby lying in the center of this solid fragment. Now it is enough for us to define the distance of the whole center point. For example, from this point I will enter 10 millimeters here, and we have the circle placed such that the circle center is offset by 10 millimeters from this edge of the solid and lies in the center of this solid fragment. I click the right mouse button now, and at this moment this line is a sketch line, and it is a regular sketch line, and this line will take part in the next stage of creating the 3D model. If I close the sketch now and choose, for example, the pad operation, a warning appeared here. Wire is not closed. And if you are learning FreeCAD, this warning might appear regularly. And the point here is that these sketch geometries intersect, and FreeCAD doesn't quite know, based on what to create the next solid fragment. For this sketch to be correct, the sketch should be one continuous geometry. And as I mentioned, this line is regular sketch geometry. And I want this geometry to be only helper geometry so that it does not take part in the next stage of creating the 3D solid. And to do this, we change such a line into a construction line, and we do this by selecting this line and choosing the toggle construction geometry operation. And now this line is construction geometry. If I close this sketch and want to create another solid fragment based on this sketch, I can do it. I click OK. Now it looks like this, and I can also create a mirrored copy of this solid feature. I can do it such that this solid fragment will be made in this spot. Or if I choose another mirror plane, this solid fragment will be made in this spot. I click OK. And I have something like this. And here we used the basic planes of the coordinate system all the time. The situation will look different if I create some geometry here. I will draw, for example, a slot more or less like this. Here 40 millimeters. This dimension does not matter. And here I will enter, for example, 4 millimeters. Okay. I click the right mouse button to cancel this command, and now I select this point, I select this point and select the x-axis, and here I choose the symmetry constraint. We have some redundant constraints. Okay, I clicked on all these constraints here, and quite a lot of these constraints are redundant, and I click the right mouse button and select the delete option. Okay, and here something went wrong. constraints that were needed were also deleted. Therefore, I press Ctrl Z and Ctrl Z again and press Ctrl Z again. And here I will try to drag this geometry a bit. Okay, here while drawing this slot, I accepted the angle dimension. Therefore, I select this dimension and press Delete. And now everything should be fine. I select this point, select the x-axis, and choose the symmetry constraint. Now I will also define the distance of the slot center from the edge of this solid fragment. I select this point and choose dimensioning. And here in this axis I enter 2 mm. I click the right mouse button, close the sketch, and based on this sketch I will create a pocket in the solid, for example to 5 mm. Okay, and now I would like to get this slot on this solid fragment but on this side. And of course we could draw such a slot. But here I just want to show you with an example how we can deal with this if we cannot use a coordinate system plane as a mirror plane, and we can create such a plane. However, what I mentioned, if you want to create a plane that is to be between two faces, in this case, I would like the construction plane to be between these two faces. Then, if you want this plane to be perfectly between these faces should be equal to each other. In this case, these faces are not equal to each other. And now if I select the Datum plane command, the plane will be created by default in this way. And here I need the plane to pass through the center of this solid fragment. And here if we rotate it around the x-axis by 90 degrees, in this axis everything looks correct. But if we wanted to mirror from here to here, we could use one of the default coordinate system planes, just like we did in this example. In this situation, we need a plane that will be perpendicular to this plane and will pass through the center of this solid fragment. And to do this, we need to use rotation around another axis here, around the y-axis, and I enter 90 degrees here. And now this plane is tilted, and this results from the fact that the surface area of this face is different from the surface area of that face. And in this way, at this moment, we cannot do this. We have to apply a slightly different approach to creating such a construction plane here. Therefore, I cancel this. Regarding construction planes, we can create construction planes based on various geometries. And as for me, I approach this more by trial and error, and sometimes I simply select two edges, I select the Datum plane command, and check what happens, how such a construction plane will be generated. Then I enter the rotation angle around the x-axis. If it doesn't suit me here, I check around the y-axis how it will look. And here too, it doesn't look good, so this is a bad approach. I cancel this. And now, for example, I select 2 points with the Control key. I go to the Datum command. And here it looks like it is good. Such a plane suits me. I click OK. Some information appeared here, some warning, but momentarily I ignore this warning. I recompute the solid, and now we can use this plane as a mirror plane. I select the feature I want to mirror. I select the mirror command, and here as the mirror plane, I select Reference and indicate this plane, and I click OK. And this warning that appeared while creating this construction plane can be ignored. Here, in this case, everything works, and often we can ignore such warnings, but we can also try to create such a plane so that the warning does not appear. Therefore, I will undo this operation now and remove this construction plane. And we can also create such a plane by indicating, for example, 4 vertices. And here, by the way, we will use the vertex selection mode. I switch only to vertex selection, and now I accidentally won't indicate either an edge or a solid face. And here, to create such a plane, we can also select 4 vertices. We do this with the Control key. We select the Datum plane command. And here too, we apply a rotation around the y-axis by 90 degrees. We click OK, and here we no longer have any warnings. I click the left mouse button to deselect all geometries. I select this operation, choose the mirror command, and here as the mirror plane, I indicate this construction plane. I click OK, and in this way, we created such a plane. And precisely sometimes cases arise where creating construction planes can be useful. Often these are cases where we need to use such a plane for a mirror operation, but we can also create sketches on such planes. And now, for example, I will create a sketch on this plane. I select this plane, I select Create Sketch, and now this plane is the sketch plane, and here I will create, for example, a sketch for the operation of removing material by rotating the sketch around a specified axis. I will create a circle, for example, with a diameter of 10 millimeters. I will switch to the view on the sketch plane, and now if I close this sketch and select the Revolve operation, an error will appear. I cannot use this sketch for this operation. Even if I change the angle here, it won't work, because for the Revolve operation or for the Groove operation, we need a sketch that will be a half section of what we want to create. Therefore, I go to edit this sketch now, and here I will draw a line like this. Okay, I click the right mouse button, and now we will do it so that this line lies in the center of the circle. Therefore, I select the line, select the point. I press the C key to apply this coincidence constraint and trim the circle fragment to have a half section. I close the sketch, and now I select the Groove operation. And here an error appeared regarding the axis of this operation. And here we have a vertical sketch axis selected, but I will switch to horizontal sketch axis. I click OK, and we have something like this. And here in this example, I wanted to show you that we can use this plane as a sketch plane as well. And in some cases, this can be useful when we want to create some geometry that does not lie on a solid face. And we can also create a sketch plane based on a solid face. If you select a face and choose the Datum plane command, a construction plane will be created based on this face. And you can move this plane. For example, we can move it in the z-axis so that this plane enters the solid a bit. We click OK, and now we have a plane that is offset by a specific distance from the solid face. And in certain situations, this can be useful. We can create a sketch on such a plane. I select Create Sketch. And here too, for example, I will create a circle. But first I will create reference geometry. I will switch to the view on the sketch plane. I select Draw Circle. I place the circle center in this spot. I draw a circle with a diameter of 10 millimeters. I close the sketch and, for example, I perform a pocket operation to 25 millimeters. I click OK, and we have something like this. So construction planes can be very useful and can allow for creating increasingly complex 3D models. Regarding construction planes, this is not all yet, and in the next example I will show you another application of construction planes and another operation for creating 3D models in 3D CAD systems. Now you can create datum planes in multiple ways, use them for mirrors and sketches, and avoid sketch errors by switching helper lines to construction geometry. In this part of the FreeCAD series, you'll learn how to create more advanced shapes using additive loft and additive pipe. We'll also use datum planes to position profiles, copy sketches between planes, and handle the small issues that can appear when moving sketches. We will now move on to the next example, and I will show you another simple but useful operation, and for this operation we will also use construction planes. I start a new project as a parametric part, and here I will start by creating a sketch on the XY plane, and I will create a polygon here, select the hexagon command, place the center of the polygon at the origin of the coordinate system, enter 50 millimeters as the dimension, press enter, and as for the angle, simply click the left mouse button on the x-axis to constrain the polygon vertex to the x-axis. We close the sketch, and now I will create another sketch on a construction plane that will be offset from the XY plane by 50 millimeters in the z-axis. I clicked the left mouse button to deselect the sketch because we can also create a construction plane relative to a sketch, but for now I want to show you how we can do it relative to the coordinate system plane. I select the datum plane command, and here by default a construction plane coinciding with the XY axis was created. However, if you would like to create a construction plane that will be, for example, offset from the XZ or YZ plane by a specific value, you need to turn on the visibility of the coordinate system. because at this moment the coordinate system is invisible, but it is in the project. Simply its visibility is turned off. And now when we create a construction plane, we can create a construction plane that coincides with the XY plane. But even here, if we change the selected options, the fields that allow for shifting and rotating the plane are inactive. Therefore, such a plane will not be needed for anything in this case. We must indicate some reference here, which will be such reference geometry relative to which we will create the construction plane. And we can do it relative to the sketch, but I also want to show you that we can do it relative to the coordinate system, and precisely what I want to show you might be useful sometimes. Sometimes there might simply be a necessity to turn on the visibility of the coordinate system and the coordinate system planes at this stage. And to do this, we select the coordinate system in the feature list and press space. And now we have the coordinate system visible. We can indicate the XY plane. And now if we select the datum plane command, the reference for creating the construction plane is the XY plane. And we can shift this, for example, in the Z axis by 50 millimeters. Okay. And we have a construction plane created. Now I select the coordinate system in the feature list, I press space, and the coordinate system is no longer visible in the workspace, and we can create another sketch on this plane. I select this plane, choose the Create Sketch command, and here I will also create a polygon. I place the start of the polygon at the origin of the coordinate system. As the dimension, I enter 30 millimeters. And as the angle, I enter, for example, 30 degrees. I press enter, and we have the shape drawn. I click the right mouse button, and here 1 degree of freedom is missing. Even though we specified the angle, this angle has not been dimensioned here. And regarding dimensioning angles, we will get to that in a moment, but in this case, I will do it so that I place this vertex on the y-axis. I select this point, select the y-axis, and choose the coincidence constraint. I close the sketch, and we have 2 such sketches. And another interesting operation in FreeCAD is the operation that allows creating a solid by lofting between profiles, and this is the additive loft operation. Select this operation, and here we indicate the profiles based on which we want to prepare the solid. I clicked on the first profile. The first profile was selected as the start profile, and here we add a section. I click Add Section and indicate this profile. I click OK, and in this way we created something like this. I will undo this operation. Regarding this operation, we can use several profiles for this operation. Here the second profile was hidden. Therefore, in the feature list, I select this profile and press space to turn on the visibility of this profile. And now relative to this profile, relative to this sketch, I will create another construction plane. And now a construction plane has been created here, and here I can apply an offset in the z-axis relative to this sketch. I entered a value of 50 millimeters. I clicked in another field, and in the preview, we see where the construction plane will be created. I click OK. And now on this plane, I would like to create the same sketch as we created at the beginning, and to avoid drawing it from scratch, we can do it in such a way that I select this sketch in the feature list, press Ctrl C, and here I deselect everything and copy only this sketch. Make sure you have the Auto Select Depending Objects option unchecked, and now we select only this sketch because we only want to copy this sketch. I click OK, and here I press Ctrl V. We have a sketch here. Only as you can see, this sketch is outside the active body. Therefore, by drag and drop, I drag this sketch to the active body, and this sketch overlaps with this sketch. Here I turned off visibility by pressing space, and as you can see, these 2 sketches are in the same place, and I wanted to move this sketch to this plane. And to do this, in the sketch properties, we have something like attachment, and here we can click this field. Then we click these dots and click this plane. Only we also deselect the XY plane. We have to click here too to deselect it. We make sure that only the construction plane is selected. And we click OK. And now this sketch we copied has been moved to this plane. And now I will create the additive loft operation. I select the start profile, choose the additive loft operation, select Add Section, and add this section, and then add section again and add the next section. I click OK, and in this way we created such a solid. Regarding construction planes, as you saw, we can move these planes along the coordinate system axis, but if I now go to edit this plane, we can also apply rotations here, and we can rotate this plane, for example, relative to the x-axis, and we can rotate this plane relative to the y-axis. I click OK, and now nothing has changed here, but I refresh the model and we have something like this. So, as you can see, this can also be useful in some cases, and something like this allows creating interesting shapes. I select these planes in the coordinate system, turn off the visibility of these planes, and here we can attempt to apply the thickness operation. However, this operation might not work in some cases, but usually it works, and here too, this operation worked. And we have such a model. Literally a few clicks, but it looks quite interesting, and you learned another operation for creating 3D solids in FreeCAD. I will now move on to the next example and show you another interesting operation for creating 3D solids in FreeCAD. We start a new project as a parametric part, and here I will start by creating a sketch on the XY plane and simply create two circles here. The first circle with a diameter of 40 millimeters, the second circle with a diameter of 60 millimeters. I close the sketch, and the second sketch will be the path along which we will sweep the first sketch. I click the left mouse button to deselect all geometries. I select the Create Sketch command, and we will create the path sketch on the XZ plane. And here I will do it in such a way that I select the polyline drawing command. I place the first point of the polyline at this point. I place the second point on the y-axis, and I place the third point more or less here. I click the left mouse button to finish drawing this polyline, and click the right mouse button again to cancel this command. Now I select the fillet command, click on this corner, and click the right mouse button to cancel this command. Now I select the dimensioning command, select the radius, and here is the radius value. I enter 50 millimeters. Next, I click on this line, and as the length of this line, I also enter 50 millimeters, and I click the left mouse button to end this command. And now I select this line, and choose the equality constraint to specify that these lines are equal to each other. I close the sketch, and now I will create a solid by sweeping these circles along this path. To do this, we select the profile sketch that we will sweep, and then we select the additive pipe operation. Next, we click the Object button, indicate the path, and you can already see in the preview what it will look like. We click OK, and we have such a solid created. Next, we can create subsequent solid fragments, and here I will create another sketch on the XY plane. I will switch to the view on the sketch plane so that the model does not obscure the view. And I select the Center Rectangle command here and indicate the option to create a rectangle with rounded corners. And I will draw a square here with a side of 100 millimeters. And a radius of 20 millimeters. I click the right mouse button to finish this. I will change this radius to 15 millimeters and select Draw Circle. And I draw 4 circles such that the centers of these circles lie at these points. And regarding the diameter of this circle, I define the diameter of the last circle, for example, as 10 millimeters. I click the right mouse button, and now I select these 4 circles and press the E key on the keyboard so that these circles are equal. I close the sketch, and now based on this sketch, I will create another solid fragment. I select the pad operation, and here by default it is prepared so that the extrusion will be made upwards, but we can use the reversed option, and the solid based on this sketch will be created in the other direction. I click OK to confirm this, And okay, we have such a solid. And now I would like to create this solid fragment on this side as well. And we could approach this by drawing another sketch, because this sketch was quite simple, so drawing such a sketch would be quite quick, but we can also use the option of moving sketches from one plane to another. And one such option is simply using this sketch. I will turn on the visibility of this sketch, and we can do it so that we create a new sketch on this face. I select this face and choose Create Sketch. And here we have an option like Carbon Copy. Let's choose this option. And now we have to indicate the sketch we want to copy. Here I have to rotate the view slightly, and now I want to indicate this sketch. However, here when I hover over this sketch, information appears in the lower part of FreeCAD that we must hold the keyboard shortcut Ctrl+Alt. After holding this keyboard shortcut, we can click on this sketch, and this sketch has been moved to this plane. I click the right mouse button to cancel the Carbon Copy command. Only here, this sketch was copied exactly in such a way that the center of this sketch is at the origin of the coordinate system, and we need to do it so that the center of this sketch is at the center of this circle, and sometimes it might happen that you will have to figure it out a bit. Therefore, here I select the external projection command and create reference geometry to this solid. I click the right mouse button, and here we have a constraint that specifies that this square is placed symmetrically relative to this point. I clicked in this spot, and this constraint was highlighted in the constraint list. I click on this constraint and select Delete here. And now I can change the position of this geometry. I can do it so that I place this sketch symmetrically relative to this point. Okay, here it is possible that I selected too much geometry. I click the left mouse button to deselect geometry. And once again, I select this point, select this point, select this point, and choose the symmetry constraint. And now everything is okay. I close the sketch, and based on this sketch, I create another solid fragment. I click OK, and we have something like this. Only here, as you can see, while creating this sketch, I did not draw circles, and this sketch was created in such a way that we simply don't have a hole here. In this case, I wanted to show you this as a curiosity, but in the next example, I will show you calmly how we can move sketches from one face to another face. Here too, a situation appeared where this sketch was not fully moved in the way we would want it to be moved, and that is why I will leave this lesson so that you know that such situations can appear, that it doesn't always work as nicely as it might seem. Sometimes simply such slight problems appear that you have to deal with in some way. Now you can loft between profiles, sweep shapes along a path, and use datum planes to control where sketches live in 3D space. In this part of the FreeCAD series, you'll learn how to copy a sketch from one face to another in two different ways. I'll show you when the copy stays linked to the source sketch, and when it becomes an independent sketch. I will now move to the next example and show you how to copy sketches from one face to another. I will show you what I showed in the previous example on a slightly less complicated part so that it is more understandable. I will create a new part here as a parametric part and create a new sketch on the XY plane. Here we will create, for example, a triangle. Select Draw Triangle and draw a triangle more or less like this. We will do it so that this vertex is on the y-axis. Here, enter 50 mm as this dimension. Press Enter, and to place the vertex on the y-axis, simply click the left mouse button when this axis is highlighted. We close the sketch, and based on this sketch, we will create a solid with a height of 20 mm. Now I will create a sample sketch on this face. I select this face, choose Create Sketch, and here I will draw some geometries. I will draw, for example, a slot. Here I enter 20 mm as the dimension of this slot, 0 degrees as the angle, and for example 2 mm as the slot width, and I press Enter. I click the right mouse button to cancel the slot drawing command. Now I will define the distance of the slot from the origin of the coordinate system. In the x-axis 15 mm, and in the y-axis. And we will create one more geometry, for example, a circle more or less in this spot with a diameter of 10 mm. And we will also define the distances of the circle's center point from the origin of the coordinate system. In the x-axis 20 millimeters, and in the y-axis, for example, 7 millimeters. Okay, I click the right mouse button to cancel this command, I close the sketch, and we have such a sample sketch here. And now I would like to create this sketch on the remaining faces of the solid as well. We can transfer such a sketch to other faces of the solid in two ways. The first way is simply copying this sketch. We select the sketch in the feature list, we press Ctrl+C. Here we deselect everything and select only the sketch because we only want to copy the sketch. If you cannot select only the sketch and other elements are selected by the way, make sure you have the Auto Select Depending Objects option unchecked. We click OK, and here we press Ctrl+V. The sketch has been copied, only this sketch is outside the body, and we have to move this sketch to the active body. Okay, we have the sketch in the active body. At this moment, these two sketches are in one place, and the sketch we copied, sketch number 2, we will move, for example, to this face. To do this, we select the sketch in the feature list. We look for the map mode property here. We click flat face here and click this button. This button will appear when you click on this field on flat face, and then we can click this button. Now we select plane here, and we can indicate the face to which we will move this sketch. We click OK, and this sketch has been moved to the second face. We click this button here to refresh the view, and we have the same sketch on the second face. Another way is to use the carbon copy option. We create a sketch on this face. We select this face and choose the Create Sketch option. And here we have a command like carbon copy. We select this command. Now we have to indicate the sketch we want to transfer. I want to transfer this sketch. To copy a sketch onto the current sketch plane, we simply have to indicate the sketch we want to copy. However, in the case of sketches that are not on a plane parallel to the sketch plane, we must hold the Ctrl+Alt keys, and then we can click on the sketch we want to copy. And the sketch has been copied to this face. We simply press the Ctrl+Alt keys and click on the sketch we want to copy. I close the sketch, and okay, we have copied sketches on the solid faces. We have the source sketch. We have the sketch we copied using the Ctrl+C, Ctrl+V command. And the sketch we copied using the carbon copy option. I will change the name of this sketch so that it is known that this is the sketch copied using the carbon copy option. Okay, and now I will go to edit the source sketch and introduce changes here. Here, for example, I will type 30 millimeters. I will change the distance to 10, and I will also change the slot width to 5, and we will change the circle diameter to 3 millimeters so that these changes are clearly visible. Here we will also change it in this way. I close the sketch and see what happened. I changed the source sketch, and the sketch created via the carbon copy option was also changed, but the sketch that was simply copied was not changed. That sketch is not linked to the source sketch, and at this moment that sketch is independent of the source sketch. And the sketch created via the carbon copy option is linked to the source sketch, and if we make dimension changes in the source sketch, the changes will also be applied to the copy of this sketch. As for the sketch we simply copied, that sketch is a regular sketch. We can make changes here, but it is simply no longer linked to the source sketch. These are the ways to copy a sketch from face to face, and in some cases, this can be very useful. Now let's see what happens if I draw some geometry in the source sketch. I will create this geometry quite freely. I close the sketch, and now, like this, we have the source sketch and we have the carbon copy sketch, and here in the copy of this sketch, the new element did not appear, and similarly in the copy created by copying the sketch, this element did not appear either. So if you want to copy sketches from face to face, create a complete source sketch first, and only then proceed to copying the geometry. Now you know the key difference. Carbon copy stays linked and updates when you change dimensions, while a normal copy does not. In this part of the FreeCAD series, you'll learn how to use additive loft and additive pipe with multiple different profiles to create smooth shape transitions. We'll also use datum planes normal to an edge so you can place end and intermediate profiles along a sweep path. I will now move to the next example, and we will return here to the additive loft and additive pipe operations. And regarding the additive loft operation, in the previous example, I showed you that we can perform this operation based on several profiles. We simply do a loft through profiles. However, all the profiles I used for the loft had the same shape. The main advantage of this operation is that this operation can create a solid by lofting through profiles, and these profiles can be different. Simply, the loft will be made to transition from one profile to another. There will simply be a smooth change of shape, and I will show you this now on a simple example. I will create another sketch on the XY plane, and here we will start, for example, by creating a circle. We will make a circle such that the center of the circle lies at the origin of the coordinate system, and we will create a circle with a diameter of 50 millimeters. We close the sketch, and relative to this circle, we create another construction plane that will be offset in the z-axis by 50 millimeters. And on this plane, we will create another sketch, and here, for example, we will draw an ellipse. Expand the circle drawing commands and select the ellipse by center command. And we place the center of the ellipse at this point. Next, we specify the first radius of the ellipse, enter 30 millimeters here, press enter. Regarding the angle, you can enter 0 degrees, or you can click the left mouse button on the x-axis, and now we specify the second radius of the ellipse. Enter 15 millimeters here and press enter. We click the right mouse button to cancel this command, and here an automatic constraint was not applied, so I select the point. Select the x-axis and press the C key so that this ellipse is fully described, fully constrained. I close the sketch, and we can create another profile, and we will create another plane that will be offset from this sketch. This sketch is selected. I select the datum plane command, and here I will also create an offset of 50 millimeters in the z-axis, and let's add a tilt relative to the y-axis, for example by 20 degrees. I click OK, and now I select this plane, and on this plane I will create a new sketch, and we will draw a center rectangle with rounded corners here. I place the center of the rectangle here, and as rectangle dimensions, I enter 25 by 20 millimeters, and as the radius, I enter 5 millimeters. I close the sketch, and we have 3 such profiles, each profile with a different shape. I select the first profile, I select the additive loft operation, and now I indicate subsequent sections. I click Add Section, I indicate this profile, and as you can see in the preview, a loft has been performed, and this loft smoothly changes shape from a circle to an ellipse. And now I add another profile. I click the Add Section button and indicate this sketch. And here we have another fragment of the loft, and this loft smoothly changes shape to adapt to the profiles. I click OK, and we have something like this. So in this operation, you can use many different profiles. Sometimes if you overcomplicate and create some strange shapes, the solid might also come out strange, but generally this operation works such that we create a loft between profiles, and this loft will be smoothly adapted to the profiles, and thanks to this, we can create quite interesting shapes. Another interesting operation is the additive pipe operation, and you already learned this operation in the previous part of this tutorial, but this operation also has an interesting function because we can perform a sweep of a profile along a path including intermediate profiles, meaning we can start from some initial profile, and then along the path we can place intermediate profiles, and in this case too, the shape of the sweep will smoothly change. I will move now to a new example, and here we create a new parametric part. We will create a sketch on the XY plane at the beginning. We will make an initial profile here and simply draw a circle with a diameter of 20 millimeters. Okay, I close the sketch, and just like in the previous example where I showed you this operation, we will create a path profile, and we will create this profile on the XZ plane. However, here a sketch was selected, and another sketch was created on the same plane. This sketch appeared in the feature list. Therefore, I right-click here, select Delete, and now I deselect this sketch and select the Create Sketch command, and now I indicate the XZ plane as the sketch plane, and here I will create a similar profile. I select the polyline drawing command and draw a polyline more or less like this. I click the right mouse button twice to end this command. Regarding the additive pipe operation, it is important that the beginning of the path along which we sweep the profile is perpendicular to this profile. That is, it should be done as in this case. The initial profile is this circle, the beginning of the path is this line, and here this line is perpendicular to this sketch. And in the next example, I will show you how to create a construction plane that will be perpendicular to the path at its starting point. But here I just want to emphasize that it should be done in such a way that the initial profile is perpendicular to the starting point of the path. In some cases, if the path is not perpendicular to the profile, it might succeed, but the solid after sweeping might be slightly deformed. And I will show you this on examples in a moment. Now we will adjust the path sketch a bit. I will add a fillet here in this corner with a radius of, for example, 30 millimeters. And here is the length of this line. I will enter 50 millimeters. I click right, select this line, and press the E key so that these lines are equal to each other. I close the sketch, and so we have the initial profile, we have the path, and we can apply the additive pipe operation here, but we can also create an end profile here. And the end profile should be created on a plane perpendicular to the path at its endpoint. And now if I want to create such a sketch, I cannot use a basic coordinate system plane to create such an end profile, but we can create a construction plane that will lie at this point and will be perpendicular to this line, meaning it will be perpendicular to the last fragment of the path. To do this, with the Control key, we select the point and select the line and select the Datum plane command. And here an error appeared, but if you click the normal to edge option, everything is okay. And a construction plane has been created that is perpendicular to the path at its endpoint. We click OK to confirm this. And now on this plane, we can create a sketch. We select this plane, select Create Sketch, and here, for example, we will create a rectangle with rounded corners. We place the center of the rectangle in this spot, and as rectangle dimensions, let's enter, for example, 20 by 20 millimeters and a radius of 5 millimeters. We close the sketch, and we have the initial profile, we have the end profile, and now we can create the additive pipe operation using intermediate profiles. In this case, we happen to have only the end profile, but in a moment we will also create subsequent profiles. First, I select the construction plane in the feature list. I press the space key to turn off the visibility of this plane, and so I select the initial sketch. I select the additive pipe operation. Next, I indicate the path along which we will sweep this profile. And here simply an additive pipe operation was created where this circle was swept along this path, but we have something here like section transformation, and here we can select transform mode, multi-section. And now by clicking the Add Section button, we can add subsequent profiles. I indicated the end profile. I click OK, and in this way, we created a solid by sweeping a profile along a path using intermediate profiles. And we can use several such profiles here. I will undo this operation. OK, and we will create another intermediate profile. For example, we will create this profile in this spot, and here we will create a construction plane. For this purpose, I select this point with the Control key. I select this line and select the Datum plane command. And here, just like before, I select the normal to edge option. I click OK. Next, I select this plane. I select Create Sketch, and here I will create, for example, an ellipse, more or less like this. We will do this freely without dimensioning. I close the sketch, and here we will create another construction plane. We will create this plane at this point. I select this point with the Control key. I select the line. I select the Datum plane command. And here, just like before, normal to edge. I click OK, and now on this plane, I create another sketch. And here we will create, for example, a slot. I will do it more or less like this. Okay, here I will also apply the symmetry constraint. We have a redundant constraint, so I remove this constraint. I will enlarge this slot a bit. Okay, and so we have intermediate profiles. I will turn off the visibility of the construction planes. I select the initial profile. I select the additive pipe operation. I click the Object button. I indicate the path along which I want to sweep these profiles. And here I switch to multi-section mode and indicate the sections sequentially between which I want to perform this sweep. I add subsequent sections and select the last section as well. And in the preview, you can already see what it will look like. I click OK, and in this way, we created such a solid. So, as you can see, these operations, both additive loft and additive pipe, can have interesting applications. And just like with previous operations where we created a 3D solid based on a sketch, so in this case, we have counterparts of these operations that remove material from the 3D solid based on a sketch, and in the next example, we will use these operations to remove material from a solid. Now you can loft between different profile shapes and create multi-section sweeps that morph smoothly along a path using datum planes. In this part of the FreeCAD series, you'll learn subtractive loft and subtractive pipe, two powerful ways to remove material with smooth shape transitions. We'll build a simple base solid, create multiple cutting profiles, and then cut a loft and a swept channel the correct parametric way. I will now move to the next project and show you the subtractive loft and subtractive pipe operations. We start a new project as a parametric part, and here I will create a sample solid from which I will remove material. I will simply create a rectangular box, for example, with dimensions of 100 by 70 millimeters. And based on this sketch, I create a solid with a height of 25 millimeters. And now regarding the subtractive loft operation, just like in the case of the additive loft operation, we simply create profiles between which we will apply this operation. And we will start by creating a sketch on this face. I select this face, choose Create Sketch, and here we will create some simple shapes. For example, I will create a rectangle with dimensions of 40 by 20 millimeters. I click the right mouse button to cancel this. Okay, we have such a rectangle. Now I select the External Projection command and click on this line to create reference geometry based on this line. And I select this point. I select this line and choose the coincidence constraint. I close the sketch. Now I will create another sketch. This time I will create a sketch on a plane passing through the center of the solid. Here I had this sketch selected and clicked the Create Sketch button. And this sketch was created on the same plane. Therefore I right-click here. I delete this sketch. Now I make sure all geometries are deselected and select the Create Sketch command and select the YZ plane as the plane on which I will create the sketch. I switch to the view on the sketch plane. And here, for example, I will create an ellipse. More or less like this. I will add dimensions to this ellipse. In this axis, 25 millimeters. Regarding the angle, I enter 0 degrees, and in this axis, for example, a radius of 10 millimeters. I click the right mouse button to cancel this. And now I also select the External Projection command. I select this line, click the right mouse button to cancel this command. I select this point, select this line, and choose the coincidence constraint. I close the sketch, and now I will create another sketch. This time, I will create a sketch on this face. I select this face. I select Create Sketch. And here I will simply create a circle whose center will lie on the y-axis, and it will be a circle with a diameter of 25 millimeters. And we will also do it so that we constrain the center of the circle to the edge of the solid. I simply select the center of the circle, select the reference geometry, and choose the coincidence constraint. I close the sketch and we have 3 profiles. And now regarding the loft operation, whether it will be the additive loft or subtractive loft operation, we can also approach this such that with the control key in the feature tree, we select the profiles between which we want to perform this operation. If I select the additive loft operation now, automatically another solid fragment will be created based on these sketches. And if I select these sketches in the operation tree and select the subtractive loft operation, based on this, material will be removed from the solid. I click OK, and we have something like this. Of course, we can also approach this such that we first select the initial profile, select the operation, and select subsequent sections. But we can also do it as I showed you a moment ago, meaning first we select all intermediate profiles and then we select the operation. And okay, applying the subtractive loft operation is very similar to the additive loft operation, only here, in the case of the additive loft operation, we create a solid based on sketches, and in the case of the subtractive loft operation, we remove material from the solid based on sketches. And the subtractive pipe operation will work similarly. I will remove the subtractive loft operation here. I select this operation and delete it. I will also delete the sketches, and we will use this box to prepare the subtractive pipe operation. And here I create a sketch on this face. I select this face, choose Create Sketch, and here I will start by creating reference geometry based on this edge of the solid. And I will draw, for example, a circle here whose center will lie more or less in this spot. Circle diameter 10 millimeters. I click the right mouse button, and I will also define the distance of this point from that point. I select these 2 points, press the D key, and here as the distance I enter 10 millimeters. I close the sketch, and now I will create a path sketch on this face. I select this face, choose Create Sketch, and here, as I mentioned to you in the previous example, the beginning of the path along which we will prepare the sweep should be perpendicular to the profile that will be swept along this path, and we will do it so that we create reference geometry here. Select the external projection command, and we can create reference geometry to this edge, but we can also create reference geometry to this sketch. And here we will create a path so that the starting point of the path lies in the center of this circle, and so that this path is perpendicular to this profile. I switch to the top view, and here we could have applied the external projection command only to this circle. I will press Ctrl Z to undo this, and this command is active. And now I select this circle, and here simply a fragment of this reference geometry has been created, and this is enough for us. I click the right mouse button to cancel this command, switch to the top view, and here I will create a path using the polyline command. At the beginning, I draw a line that will be perpendicular to the profile. I make sure that a fragment of this polyline will be vertical, and then I draw subsequent fragments of the path. We will do it more or less like this. I click the right mouse button twice to end this command, and here we will also use the external projection command to create reference geometry to this edge. I click the right mouse button, and we do it like this. I select this point, and choose the coincidence constraint. And here in this case, we will do it so that I select this point, and select this point, and choose the symmetry constraint. Now we can add fillets at these points here so that there are no such sharp breaks in the path. I simply select the fillet command and select these path points. I click the right mouse button, and now I select 3 radii. I press the E key to specify that these radii are equal to each other. I select one radius, press the D key, and specify the dimension of this radius, for example as 10 millimeters. And okay, I will not dimension this path anymore. I close the sketch, and now we will use the subtractive pipe operation. We select the initial profile. With the Control key, we select the path, and we select the subtractive pipe operation. And here, as you can see, we also don't have to select the path. After selecting this operation, we can select the profile, we can select the path, and the operation will be applied. but we can also do it step by step. We select the profile sketch, select the subtractive pipe operation, and then click the object button and select the path so as to prepare the sweep along this path. But here, instead of sketches, I selected the solid, so I click the object button again and select this sketch. I click OK, and we have something like this. So as you can see, these operations, both additive loft, additive pipe, as well as subtractive loft and subtractive pipe, can be very useful in many cases and allow for creating quite complex 3D solids. Now you know how to cut complex shapes using subtractive loft and create smooth channels using subtractive pipe with a properly built path. In this part, we'll focus on one of the biggest advantages of FreeCAD, parametric modeling. I'll show you how to create variables in sketches, link dimensions with expressions, reuse parameters across features, and even create multiple size variants of the same part by changing a single value. If this topic was helpful and you want to learn more about parameters in FreeCAD, I've got a dedicated course that goes into more detail. You can find the link in the description. We have already discussed most of the 3D solid creation operations in FreeCAD, and now we will go back to the basics a bit, but also to a huge advantage of FreeCAD. That is, we will focus a bit on parameters. Using a simple example, I will show you how you can utilize the parametric capabilities of FreeCAD. I will create a new example in the part design workbench and create a new sketch on the XY plane. I will draw a rectangle here, placing its center point at the origin of the coordinate system, and for the dimensions of the rectangle, I will enter 100 by 70 millimeters. I right-click to cancel the command. Okay, we have our sketch. As I mentioned before, FreeCAD is parametric software. In this case, the dimensions are parameters, and we can change these parameters, but we can also link these parameters together. We can set it up so that, for example, the shorter side of the rectangle is always a certain fraction of the long side. To do this, we first define this dimension as a variable. We double-click here with the left mouse button, and we have the name field. We will name this dimension L1. I click OK. Now, I would like this dimension to be 70% of the value of that dimension, and we can do this very easily. We double-click here with the left mouse button and we have the Enter Expression button. We click this button and enter the value here. We can enter a mathematical operation, but we can also use the variable we entered earlier. However, if you just type L1 now, you cannot use that variable. We must refer to the constraints. Dimensions in a sketch are constraints, so first we type constraints. I move the arrow down to select constraints. Now I type L. I move the arrow down to use the parameter L1. Then I type the mathematical operation times 0.7. I click OK. I click OK. Now we have information that this dimension is a result dimension. If I change the value of this dimension, the value of that dimension will also be changed. I close the sketch. Now, based on this sketch, I would like to obtain a solid that will have a height equal to 10% of the length of that side of the rectangle. Here, in the pad operation, we can also use the variable L1. To do this, we click this button, and here we must refer to the sketch where that variable is located. So at the beginning, we type sketch. We select the sketch that contains the variable. Sketches in FreeCAD have names. By default, if you create another sketch, it will have a subsequent number, but we can change the names of these sketches. If you have more sketches and want to refer to a specific one, it is worth changing the name to one that is easy to locate. Here I am referring to the first sketch. At this moment, we only have one sketch in the project. Next, I refer to constraints, and then to the parameter L1. I divide this parameter L1 by 10. I click OK. I click OK. Now, if I change the length dimension of the side of the rectangle, for example, I enter a value of 200 millimeters, the length of that side changes, and the height of the solid changes as well. As for this parameter L1, we can also refer to it in the next sketch. I will create another part of the solid. I create a sketch on this face. I select Create Sketch, and here I will create a circle whose center will lie at this point. I would like the diameter of this circle to be half the length of the side of the rectangle. For now, I draw a circle with an arbitrary diameter and select Dimensioning. I define the dimension of the circle, and here I use an equation and refer to the first sketch. As you can see, we already have 2 sketches on the list, but I choose the first sketch because the variable is in the first sketch, then Constraints, L1, and we divide this by 2. I click OK. I click OK. I close the sketch. And based on this sketch, I will create another part of the solid. Here I will also use a constraint and refer to the variable L1. And we will divide it by, for example, 8. As you can see, I didn't select the L1 variable yet. Okay, I select L1 and divide it by 8. I click OK, and we have something like this. Now, by changing one dimension, the entire model will adjust to that dimension. To change this dimension, we can do it from the Properties panel. I expand the pad operation, select this sketch, and here in the Sketch Constraints Properties, we have the L1 parameter. I can change this parameter. I'll enter 100 millimeters here, for example, and the entire model has been adjusted. So, as you can see, something like this is a huge advantage of parametric 3D CAD systems and a huge advantage of FreeCAD. If necessary, we can build a 3D model so that we can control the entire model using one dimension, one parameter. Of course, this is just an example to show you that we can control the entire model with one dimension. In many cases, this won't apply, but very often there are situations where one part of the model, one fragment of the model, depends in some way on the dimensions of another fragment of the model, and that's when we can use this. This can be very useful because if 2 fragments of the model are linked together and we introduce changes, if we link them properly, then we only need to introduce changes in one fragment of the 3D model, and the second fragment of the model will be adjusted to those changes. I think that when creating your own 3D models, you may encounter situations where introducing such links can significantly simplify and speed up the creation and editing of the 3D model. Another possibility for using and linking individual elements of a solid together is creating dimensional variants of parts. Let's assume this is the first dimensional variant of this part. I will change the name of this body to P1. Okay, and now I will copy the entire solid. I select the body, I press Ctrl plus C, I select everything here. Okay, and I press Ctrl plus V. A second body has been created. I change the name of this body to P2. Okay, and now I go to edit this parameter. Here I enter 150, for example. I press Enter, and we have a second variant of the solid. Now I select body P2, I press the space bar to turn off the visibility of this body, and here we have P1. I press the space bar to turn off the visibility of P1. Next, I select P2, I press the space bar and turn on the visibility of the second solid. I press Ctrl plus V again. Another solid has been pasted based on the first solid. I select the second solid. I press the spacebar to turn off the visibility of that solid. I change the name of the third solid to P3. And I go to edit the parameter. Here I enter 200, for example. I press Enter, and I have created another dimensional variant of this part. By editing a single parameter, I have created additional solids and additional dimensional variants of this part in a relatively short time. So, this is another example of the capabilities of FreeCAD in part design. You now know how to build smart parametric parts using named constraints and expressions, and how to create multiple size variants in seconds. In this lesson, we will go back to basics and discuss the pad and pocket operations in a bit more detail, because these are the 2 most frequently used operations when creating 3D models. Besides the fact that we can use these operations as a regular extrusion or a regular pocket, they also have appropriate modes that can speed up and facilitate the creation of 3D models. Since these operations are used very often and at the initial stage of learning 3D modeling, these are the main operations used. In my opinion, it is worth devoting a little more time to these operations and familiarizing yourself with their capabilities. I will start a new project as a parametric part, and here I will start by creating a sketch on the XZ plane. I select this plane, I choose this plane as the sketch plane, and now select the polyline drawing command. I will draw a polyline such that the first point of the polyline lies at the origin of the coordinate system. I place the second point of the polyline on the y-axis and draw a shape more or less like this, making sure that the geometries are vertical or horizontal. As you can see at this moment, next to the polyline there is a constraint symbol specifying that this line will be horizontal geometry. If I change the position of this line a bit, this symbol disappears. So when this symbol is active next to the line, we click the left mouse button. And now this line is a horizontal line, the previous line is a vertical line, and here we draw another vertical line, then a horizontal line, and so on. We create a very simple shape, and we will use this shape to discuss the types of pad and pocket operations. And here we finish this polyline. I clicked the right mouse button to cancel this command. And now I will add constraints here. Regarding adding constraints and using different commands in FreeCAD, these commands have keyboard shortcuts. In some commands, this keyboard shortcut involves pressing 2 letters, so contrary to appearances, it is not that fast, but for example, in the case of constraints, the keyboard shortcut is 1 letter. For example, the equality constraint is the letter E, the coincidence constraint is the letter C, and so on and so forth. Constraints are assigned to single letters, so it is worth using this because it can also speed up sketch creation. Of course, if you want to use shortcuts to call basic geometries, you can also do that. And here in the case of the rectangle, it is the keyboard shortcut GR. We simply have to press 2 letters, and this command is active. And here you can approach this such that notice when you hover over these commands, for each of these commands, the first letter of the keyboard shortcut is the letter G. And here we have line, that is GL. Then arc, that is GA. Then circle, that is GC, and so on and so forth. This might also make it a bit easier to understand these shortcuts. We simply select the shortcut G from geometry and then select the letter of the geometry we want to create. For example, GL draws a line. However, pressing 2 letters on the keyboard will not necessarily be faster than clicking an icon, but regarding pressing 1 key on the keyboard, that can already be faster and more convenient than pressing an icon. And okay, now we will use these constraints and apply constraints to these geometries by pressing letters on the keyboard. First, I select this line and this line. I press the E key. Now I select this line, and this line, and I also press the E key. Next, I select these lines, and here I also press the E key. Now I select this line and press the E key. Now I select this line, press the D key, and here as the dimension value I enter 30. I press enter. Next, I select this line. As the dimension value I enter 10, press enter. Now I select this line, and as the dimension value I enter 20, and I select this line. And here too, as the dimension value, I can enter 20. Or if it is supposed to be 20, we can approach it such that I select this line. This line is dimensioned. And I select this line and press the E key to define an equality constraint here. And here this line was linked to this line, so a constraint was applied here as well. And as you can see, by applying constraints, we defined only 3 dimensions, and the entire geometry is already fully defined, fully constrained. In my opinion, if you create geometry, besides the fact that this geometry should be fully constrained, it is worth doing it so as to use geometric constraints as much as possible. We use these commands here to use constraints as often as possible, and use dimensions only where necessary. because now if we need to make some changes in the sketch, it is enough that we change one dimension. For example, here I enter the value 15 and these three geometries changed. I will return to the value of 10 here, and we have these geometries changed back, and changing one dimension affects a larger number of geometries. Of course, this applies when we can do something like this, because if there was a situation where these lines were supposed to have different lengths, well then we cannot apply the equality constraint. Instead, we have to dimension each of these lines. But if we have a situation where in the sketch we have several geometries with the same dimensions, then a much better solution is using geometric constraints than dimensioning each geometry separately. And here I will also emphasize that dimensioning each geometry separately is not an error, because by dimensioning geometry we also remove degrees of freedom. And this geometry will be described, and the sketch will be correct. Just here it simply has a more practical aspect, and in my opinion, it is convenient. If we have fewer dimensions and more relations between geometries. Later it is simply easier to control such geometry. Regarding constraints, we have all constraints here in the constraint list, and we can simply browse these constraints. It might not be very visible when this geometry is green, but if you click on a constraint in the constraint list, this constraint is highlighted here, and we can simply trace what constraints we have applied. Here, for example, I selected constraint 31. And this constraint was highlighted here, and it is visible that this constraint concerns exactly these geometries. At this moment, this might not be entirely clear yet, because regarding working in 3D CAD systems, and generally regarding learning anything, at the beginning many things might overwhelm us, might not be that intuitive, but it is not worth getting discouraged because many things require practice, and once you create a dozen or so projects yourself, even if they are simple geometries, you will start to understand what it is all about. Learning looks different if you watch a tutorial, and learning looks different if you do something yourself. So a tutorial is a good place to start, but still you will learn the most by executing projects yourself. So I encourage you to do projects yourself. I also encourage you to experiment. Don't be afraid to use commands you don't know. Simply select a command, click, see how it works. See what happens, see what the effect will be, because something like that is also good learning, a good lesson, and it is worth spending some time on such clicking and checking what happens. And okay, now I will return to this sketch. As you remember, we created this sketch on the XZ plane. I close the sketch. Here, if you want, we can turn on the visibility of the coordinate system to see what it looks like. Okay, I will leave this coordinate system turned on for a moment, and now based on this sketch, I want to create a solid by extruding the sketch, so I select the pad operation. Okay, nothing happened here because the coordinate system was selected, not the sketch. I select the sketch based on which I want to perform this operation and select this operation. And here an extrusion of 10 millimeters from the sketch plane was created, and here we can simply change the value of this extrusion. We can enter a specific extrusion value. And this is the most basic variant of the pad operation, meaning based on a sketch, we create a solid by extruding the sketch to a specific value. But in this case, I would like this extrusion to be performed in two directions from the sketch plane. And here, as you can see, we have the mode section, and we can choose one-sided, that is extrusion in one direction. We can choose the two-sided option, and we can specify the extrusion length in two directions. And here we can do it such that in one direction from the sketch plane we will have an extrusion to one value, and in the other direction we will have a different value. And this too can be useful in some cases. But in this case I would like to use the symmetric option so that the extrusion is performed in two directions from the sketch plane to the same value. And here we specify the total extrusion value. Enter 50 millimeters here. I click the left mouse button next to the field to update the preview, and we have an extrusion of 50 millimeters performed in two directions from the sketch plane. And in this case, it looks like we have an extrusion of 25 millimeters in one direction from the sketch plane and 25 millimeters in the other direction from the sketch plane, meaning the total extrusion length is 50 millimeters. That is what I wanted to achieve, so I click OK, and we have such a solid. And now I will create a mirror copy of this solid. I select this solid, I select the mirror operation. You already know this operation, and here I want to obtain a copy of this solid on the other side of the YZ plane. I can leave the vertical sketch axis option here, or I select the base YZ plane here. I click OK, and I have something like this. Now I will turn off the visibility of the coordinate system. I select the coordinate system and press space, and I have such a solid. And now based on this solid, I will show you more possibilities of the pad operation, and then I will show you more possibilities of the pocket operation. Okay, now I click the left mouse button in the workspace to deselect all geometries to make sure no geometry is selected, and I select the Create Sketch command. And here I will create a sketch on the YZ plane. We can also select this plane here in this list. I select this plane and click OK. Now I click the Toggle Section View button to switch to the view on the sketch plane. And here I will create simple geometry. At the beginning, I will use the External Projection command to create reference geometry to this edge of the solid. I click the right mouse button to cancel this command. If this line is not a dashed line, click this Toggle Construction Geometry icon to switch to a construction line. By default, it should be a construction line, but it might be changed in settings that this line will be a continuous line, and it is important that it is simply a helper sketch line, that this geometry does not take part in the further stage of creating the 3D solid. And here I will draw a circle. I select Draw Circle and place the center of the circle on this line, and as the circle diameter 10 millimeters, I click the right mouse button to cancel this command. I select this point, I press the D key to activate dimensioning, and here as the distance I also enter 10 millimeters. I close the sketch, and I have something like this. I intentionally created simple geometry here to discuss the parameters of the pad operation based on simple geometry so that everything is clearly visible. And so I select the pad operation, and here as standard we create an extrusion to a specific distance. In the preview, you see what it will look like. At this moment, the next solid fragment based on this sketch will be created in this direction, but if you would like to do it in the other direction, you can check the reversed option here. And the extrusion will be created in this direction. Okay, I will uncheck this option for now, and often in such cases, if we create an extrusion, we create this extrusion to some feature of the solid, and in these situations the type section is very useful, where we can specify the extrusion type. In this case, a very useful extrusion type is the up to face type. If we select this, we can manually indicate a face on the model to which the extrusion is to be performed. If you want to change the face, click Select Face and indicate another face. And for me, this is the most useful type of pad operation, but we also have other types that might be useful. I will return to the dimension type, where we specify a specific value. And now I will choose, for example, to last. And the extrusion was performed to the last feature of the solid. If you check the reversed option in this case, it will be performed in the other direction. And if you would like an extrusion to be performed within this operation, both in one and the other direction through the entire solid, we switch here to the symmetric option, and it will be performed in such a way. If, for example, you would like it to be performed through the entire solid on one side and to a selected face on the other side, we change the type here to two-sided. And as the extrusion in the second direction, we switch to up to face and indicate the face to which the extrusion is to be performed. So, as you can see, we have a very simple operation, the pad operation, and inside this operation, we have quite a lot of possibilities for creating 3D solids. And knowing these operation types can really facilitate and speed up creating 3D models. And in my opinion, it is worth getting familiar with this at the initial stage of learning FreeCAD, because as I already said, the pad operation and the pocket operation are very frequently used operations when creating 3D solids, and when learning 3D modeling in 3D CAD systems, these are mainly the operations used. Okay, here for a moment I will return to the one-sided option, and we also have the to first option here, and then the extrusion will be performed to the first encountered feature. So this too can be useful in some cases, and it is simply worth familiarizing yourself with these options. And here we also have the angle option, but we will return to that in a moment. and I will perform this operation in such a way that I select the symmetric option here, and here I select to last. And we have something like this. Regarding the to last type, it is also worth paying attention to the offset to face parameter. And in this case, we can extend the extrusion, or by entering negative values here, we can shorten it a bit. Here, if the offset value is 0, it will be performed to the last encountered feature in one and the other direction from the sketch plane, but we can precisely use the offset parameter and extend or shorten it a bit. And it will also work similarly if we choose the up to face option and indicate the face to which the extrusion is to be performed. And here too, we can use the offset to face parameter, and then we can extend or shorten this extrusion. So this too can be useful in some cases. I return here to the symmetric to last option and leave it this way. I click OK, and we have created another solid fragment, and the next solid fragment was joined with the previous solid fragment. And okay, the pocket operation will work similarly. I will create another sketch also on the YZ plane. Okay, and I will also create a circle here in the same way as for the pad operation. It is a circle with a diameter of 10 millimeters and the distance of the circle center from the solid edge 10 millimeters. I close the sketch and select the pocket operation. And here, as you can see in the preview, just like in the case of the pad operation, we can also create a pocket to a specific depth. We can use the through all option. And here the extrusion will be performed through everything. And just like in the case of the pocket operation, we can switch here to the symmetric option. And now it will be performed in two directions. I will return to the one-sided option, and here instead of through all, I will choose the up to face option and manually indicate the face to which the pocket is to be performed. For example, we can indicate this face, and here a pocket will be simply performed to this face, but I can also indicate, for example, this face. Although here in this case, we could indicate this face, or we can use the to first option, and then the extrusion will be performed to this face. Here I will change to up to face, and indicate this face now. Okay, the pocket looks like this, and if I switch to first, the pocket is performed to the first encountered feature. And here in these cases, we also have the offset to face parameter, and we can shorten or extend it. So here, as you can see, the pocket operation works very similarly. The difference is that just as in the pad operation, we create another solid fragment based on a sketch. In the case of the pocket operation, we remove material from the solid based on a sketch. And here we will do it similarly to the pad operation. We will also create an extrusion through everything, only here if you choose through all. In the preview, this extrusion looks like it goes beyond the solid. Of course, in this case for this solid it won't matter, but if you don't like it and prefer to be sure that it will be performed only to this face, it is better to simply use the up to face option and manually indicate the face to which this material removal is to be performed. Okay, here we have something like this. I will change the offset to 0. And if you would like to make an extrusion in the other direction, we can use the symmetric option here. And here it will be performed symmetrically to the same distance as the pocket in the first direction, or simply choose two-sided, and as the pocket in the second direction, also do up to face and indicate this face. Of course, in this case, it won't be an error if we do it such that we select the symmetric option, and here select through all. That won't be an error either. We click OK, and we have something like this. Here regarding this option, recently in FreeCAD we can create multiple solids within one body, and such an operation, the through all operation, might affect other solids. This is a slightly more complex issue which I don't want to introduce at this moment, but I want you to know that the through all option might also affect other solids that will be inside this body. So in this case it is not an error, but cases might appear where if you apply this, it will also affect other solids that will be in this active body. I try to do it so that in one body there is one single solid, so using this type of operation is not an error, but you might have different needs in the future and might create several different solids within one body, and then performing this operation in such a way might already be an error and might also affect other solids in the project. So for now, I can leave it this way, and in this case, that's what it looks like. Now, as a presentation, I will show you what I meant here with this through all operation type if we had more solids in the project. As I mentioned recently in FreeCAD, we can create multiple solids within one body. Previously, this was unacceptable. Within one body, there had to be one single solid. Now we can turn on an option here that allows creating multiple solids within one body. And here I will create another sketch on the XY plane. You don't have to do this. I will just do it as a presentation, and I will create a rectangle here more or less like this. Okay. And here I will create an extrusion and select up to face as the type, and indicate this face so that this solid has the same height. Here I will remove this pocket operation because this operation is before creating this solid, so it won't affect this solid. Therefore, I delete this pocket operation. Okay, here it also affects this solid. I go to edit this solid and indicate this face as the face to which this solid will be performed, because here we removed the pocket operation and the definition of this face, which I indicated earlier, changed. Such situations can also appear if in the next stage of the solid you use some feature from the previous stage of the solid and you remove or modify this feature, because regarding such simple changes where we change dimensions, everything rather works. But in this case, if I removed this pocket, I also removed this face. Here previously this face was divided by this pocket. After removing the pocket, the definition of this face changed, and I used this face as reference geometry to create the next solid within this body, and after removing this face, this reference simply disappeared and the reference had to be indicated again. I know that at this stage it might already be a bit complicated, but I hope you have gone through the earlier lessons of this course and more or less understand what it is about, but all this will come out in practice. When such situations appear for you, you will be able to return to this lesson and then it will be more understandable. And okay, I have a sketch here, and based on this sketch, I will perform a pocket in the solid, and here I immediately select the symmetric option and select the through all option. And now as you can see, this pocket is performed through all solids in the project. If you want to perform a pocket only on this solid, we must edit this operation. And here we will use the two-sided option and select the up to face option. We indicate the face to which we will perform the pocket. And here too, we select up to face and indicate the face to which we will perform the pocket. And now, this operation does not affect this solid. If we select through all, it simply affects the entire project, and it will work similarly with the pad operation. So here this is already a slightly more complex issue, and it is worth it for you to execute a few projects yourself before trying to understand this issue. Then it will certainly be easier to understand what is going on here. Okay, now I will show you the option to create an angled extrusion. I will create another sketch on this face, and here we will make a sketch with reasonably arbitrary dimensions. I will draw a rectangle more or less like this. Okay, I select the pad operation, and here I will enter an extrusion value of 20. And we can create an angled extrusion here. We can do it in such a way that it expands, or by using negative values, we can do it in such a way that it tapers, so that simply an extrusion with angled walls towards the inside of the solid is performed here. I click OK, and we have something like this. And in a similar way, we can create a pocket. We can also use the taper angle parameter in the pocket operation. And just like in the case of the pad operation, we can make a pocket such that these walls expand, or by entering negative values, we can do it in such a way. And okay, the pad operation and the pocket operation are very simple operations, but as you can see, we have many available types of this operation here, and in many cases, such types of these operations can be very useful, can facilitate and speed up the creation of 3D models. I know that at the beginning this might be a bit overwhelming, it might be too much information, but if you start executing your projects yourself and test these options yourself, many things will clarify. And here I simply wanted to show you that there are such options and that you can use these options. And simply when you start making 3D models yourself, everything will certainly be much more understandable. You now have a complete understanding of almost every option within the pad and pocket tools, including how to handle complex multi-solid cuts. In the previous lesson, I briefly mentioned that we can create multiple solids within a single body. This is a fairly new feature regarding FreeCAD. Previously, in older versions of FreeCAD, this wasn't possible and had to be avoided because creating two elements within a single body always caused errors or warnings. Now this option is available, and we can do this. It is a new option, and it seems to me that sometimes errors related to it might appear, but since such a thing is available, I think it is worth learning. I am creating a new project as a parametric part, and I will show you how it looked before. I select Create Sketch, and here, for example, I will create a circle whose center will lie at the origin point of the coordinate system. I will create a circle with a diameter of 40 millimeters, and I will create, for example, a slot here. I place the first point more or less here. As the slot dimension, I type 50. I press Enter. I place the slot point on the x-axis. And now, as the slot width, I type 25 millimeters and press Enter. I right-click to cancel this command. I select this point, I press the D key, and here is the distance. I type 120 millimeters. I close the sketch and now select the pad operation. And here we have a warning that the result of this operation is a multi-solid part, and we must allow FreeCAD to create such solids. If I click OK now, a warning appears here. And if you want to enable something like this in FreeCAD, we can do it individually for each body. We select the body, and here we have an option that allows creating multi-object parts within a single body. We check it, and now based on such sketches that do not touch, we can create a solid. Okay, here I need to select the sketch. I select the pad operation, extrusion by 10 millimeters. Okay, and now we can do such a thing. Until recently, this was an experimental option in FreeCAD version 1.0 RC2, meaning the trial version released before the official version was made available. It is now a normal FreeCAD option. It is not defined as an experimental option, so I think we can slowly get used to this option. If you want this option to be enabled by default, go to Preferences. On Mac, expand the FreeCAD menu and select Preferences. On Windows, expand the Edit menu and select Preferences. Next, we go to the Part Design tab, and here we check the option that allows creating multi-object parts within a single body in the Part Design module. We click OK, and now this option will be checked by default, and in some cases this can be a truly huge advantage. And now, for example, we can create another fragment of the solid. I select Create Sketch on the XZ plane. OK. And I will use these two solids as external geometry to create another fragment of the solid. I will create a polyline here, for example. Note here that when I hover over this reference line, I can place the start of the polyline on this line, or if I get close to the center of this line, a symmetry constraint appears, which will place the start point of the newly drawn line at the center of the reference geometry. Here in the preview, you can see how the constraint symbol changes. When I hover near the midpoint of this line, the symmetry constraint appears. If I move a bit to the side, the coincident constraint symbol appears. I hover near the midpoint of this line, click the left mouse button, and draw the polyline more or less in this way. And here I would also like to draw this polyline so that it ends in this place. That's why I place this point of the polyline more or less here and hover over this line. And here we have two constraints. A symmetry constraint appears, and a constraint that determines that this line I am drawing will be a vertical line. I click in this spot, right-click to finish drawing this polyline, and right-click again to cancel this command. And here I will also add fillets in the corners of this polyline. I select the command that allows creating fillets. I right-click to cancel it. I press the D key to activate the dimensioning command. I select this fillet, and here as the radius value I type 20. OK, I select this line and type 30 as the length of this line. I right-click to cancel the dimensioning command, and here we still need to define relations. I select this fillet and press the E key. And here, at this moment, the sketch is already fully defined, fully constrained. I close this sketch. And now I will create further geometries. I will create geometry on this face of the solid. I select this face and choose Create Sketch. And here I will draw a slot whose first point will lie at the point of this line. For now, I right-click to cancel this command and I select the external geometry command to create reference geometry for this line. I care about this point because I want to use this point as the spot where I will place one of the slot points. I select the slot command and I place the first point of the slot in this place. As the slot dimension, I type 20, I press enter, and now I place the second point of the slot on the x-axis. When the x-axis is highlighted, I click the left mouse button. I don't have to do it exactly in this spot. I can click even here, and the second point of the slot will be constrained to the x-axis. And here, as the slot width, I type 5 millimeters. I press enter, and we have the slot created. I close the sketch, and now I will create another geometry on this face. I select this face, choose Create Sketch, and here I also select the slot command. Here, I will place the first point of the slot specifically at the origin point of the coordinate system. That's why I click in this spot. As the slot dimension, I will type 20 millimeters. I press enter. I place the second point of the slot on the y-axis. When the y-axis is highlighted, I click the left mouse button, and as the slot width, I will type, for example, 4 millimeters and press enter. I right-click to cancel this command. And here, however, I would like to change the position of this slot. I would like to place this slot so that the origin point of the coordinate system is at the center of the slot, so I want to move this slot a little. And here, at this moment, I cannot do that. I cannot move this slot because this slot is fully constrained. I need to locate the constraint I added here, which constrain the slot point to the origin point of the coordinate system, and it will be one of the constraints at the end of the constraints list. I select the constraints available on the constraints list, and it seems to me that it will be constraint 8, because when I click on constraint 8, this point gets highlighted. And here, regarding the other constraints, as you can see, these constraints are clearly visible in the drawing. But if we use a point-to-point coincidence, this constraint symbol is not displayed, and it is a bit difficult to locate this constraint, but I more or less know which constraint it is. I know it is a coincident constraint, so I look for this constraint on the list, and after clicking this constraint, this specific point highlights, and I can delete this constraint. I right-click here, select Delete, and now I can change the position of this slot. This point is constrained to the y-axis, so when I grab this point, the slot will not be rotated. But this point no longer has any constraint, so if I grab this point, I can change the position of this point, but here I want to apply a symmetry constraint anyway. Therefore, I select this point, I select this point, and I select this point as the third point, which will be the symmetry point, and I press the S key. And here the symmetry constraint has been applied, so Here in this example, I also wanted to show you that sometimes when we create some geometry, everything might not be clear immediately, and sometimes you need to remove a constraint. And you can do this by selecting the constraint on the geometry, or you can simply look for this constraint on the constraints list. These constraints on this list appear sequentially. At the beginning, automatic constraints appear, which are created during geometry creation, and then we have those constraints that we add ourselves. And sometimes it is easy to locate the constraint we care about, and sometimes you just have to track all constraints to find the right one. And okay, I have this geometry here. I close the sketch, and now I will use the additive pipe operation and perform a sweep of this profile along this path with a shape change to this end profile. And to do this, I select the start profile. I choose the additive pipe operation. Next, I click the object button and indicate the path. And here this sweep looks like this. And now I go to section transformation. I select multi-section, click the add section button, and indicate this sketch as the end profile. I click OK, and we have something like this. I wanted to show this here as a curiosity. Previously, in older versions of FreeCAD, if you wanted to create something like this, you had to do it in such a way that first we created this fragment of the solid, later we created sketches of profiles and paths, we created the additive pipe operation, and only then could we create a sketch on the end face of this solid fragment, and we could create another fragment of the solid. Now, in the new version of FreeCAD, we can start, as it were, from the base, and later we can connect this base. Of course, this is just an example, and the possibility of creating multi-object parts within a single body can be useful in many different situations. So it is worth knowing about such a possibility, especially if you had contact with FreeCAD a few years ago and back then it was not possible. Now we can do this and we can use it. And okay, we will end this lesson here. We're coming to the end of this training. The goal of this guide was to take you through the basic 3D modeling operations in FreeCAD, and I hope this tutorial will make it easier for you to get to know FreeCAD and continue working on your own. At the end, I'll show you how to make something like this in FreeCAD. These are two separate solids, which can then be exported to the step format, and based on these solids we can prepare a multicolor print. I'll now move to a new project. I start creating a part here as a parametric part, and here I choose to create a sketch, and we'll create a sketch on the XY plane. And we'll create here an initial base of this keychain. I choose the rectangle tool and I choose rounded corners. I place the first point of the rectangle in this place, and as the rectangle dimensions I enter 60 by 25, and a corner radius of 3. These are initial dimensions. Later we'll edit these dimensions to adjust the size of the keychain to the text. Now I choose drawing a circle, and I'll create a circle with a diameter of 3. I right-click to cancel this command. And now we'll place this circle symmetrically between these points, so I select these 2 points. Then I select the circle center, and I choose the symmetry constraint. I close the sketch. And based on this sketch, I'll create a solid by extruding the sketch, but here I choose the reversed option and the solid height 3. And I click OK. Now I switch to the draft workbench, and here I choose the shape from text command. I'll set the view to top. And I enter here the text I want to place on the keychain, and I select the font file. Here we click the 3 dots, point to the font file, and enter the text that is supposed to be on the keychain, and we click more or less in this place to place the starting point of the text here, and I click OK. And the text has been created like this. And now in the properties of this object we can make changes, and we can, for example, change the text height. Here, from 10, I'll change it to 9. I click in the field next to it so that the dimension updates, and I also change the position. Here I selected changing the position of this text along the y-axis. And by scrolling the mouse wheel, I adjust the position of this text. In a moment we'll still change this after we adjust the height of this plate. I go to the Part Design workbench, and here I go to edit this sketch. I double-click with the left mouse button, and I'll change the height of this plate from 25, for example, to 15 or to 20. Okay, and I close the sketch, and now I select this shape string object, and I'll change the position of this object. We'll do it more or less like this. We'll leave it like that. And now, this object is outside the active body, and I would like to create a pocket in the solid based on this object, so I grab this object and drag it into the active body. And now I can use this object to create a pocket in this solid. I choose the pocket operation, and here, as the pocket depth, I enter 0.76. I click OK, and I have a pocket created, and OK. For now, we have one part of the solid, and now I'll show you how you can create the second part of the solid, so that on this basis, you can easily prepare a multicolor print. We create a new body, and into this new body we'll copy this shape string object. I simply select this object here, I press Ctrl+C, and here I press Ctrl+V. This object was copied outside body 001, so I grab and drag the shape string object into the body 001 object. And now this shape string element, this text, is in body 001, and based on this object we'll create another solid. For the moment I'll turn off the visibility of the first solid, I select the first body in the feature tree and press space. And now I double-click with the left mouse button on body 001 so that this body is active. I select the shape string element and I choose the pad operation. Here, just like before, I choose the reversed option, and I set the height of this solid to 0.76. And I click OK. And now I turn on the visibility of the first body, and here we have two separate solids. And now, with the Control key, I select these two solids in the feature tree. And from the File menu, I choose Export. Here I set the location and the file name. We choose the step format and click Save. Here we click OK, and this is how we can create solids of this type. And now I'll move to Bamboo Studio. Here I'll delete this object that I imported earlier, and I add the project that we just created. I point to the file. I click Open. OK. And here this model has been imported, but only one model was imported. I exported it wrong here. OK, let's do it like this. I select this model, and with the Control key, I select this model. Here I make sure that both models are selected. And once again, File, Export. We set the location and the file name. Here I'll enter a different name to see how it gets exported. Here it's important that what we want to export is selected and highlighted in the work area. Because as you saw earlier, it's possible that I didn't select two solids and only one solid was exported. I remove this project from Bamboo Studio, and once again I add the project that we just exported. I point to this file and click Open. Here I click OK, and here, if we go to the Objects tab, you can already see that we have two solids exported. And now, for this second solid, for the text, we can change the color here. And this is how we can prepare a multicolor print. So, as you can see, in a fairly easy way, we can do things like this in FreeCAD. And we'll end this training here. It was quite a long training, but FreeCAD has many more possibilities. However, in order to learn further possibilities, it's worth mastering the basics, and I hope this guide made that easier.